पूरे बोले
Hello. So, very good afternoon to all of you. We are at
Motilal Nehru National Institute of Technology, Allahabad, for attending a course on sustainable engineering, determination of water and energy footprints using life cycle assessment. And this course will be delivered by Dr. Nawshad Haque, a very well-known scientist from CSIRO, Australia, the leading research organization having more than 60 labs and more than 6,000 technical staffs including scientists in Australia. Dr. Nawshad Haque is the group leader of energy and minerals processing. So, Dr. Haque has extensively studied life cycle assessment in variety of metals, including aluminum, magnesium, ferroalloy, gold and nickel, to identify the opportunities for CO2 emission reduction. Dr. Haque, he started his work as a material scientist in New Zealand, and in 2005 he joined CSIRO. Dr. Haque has been awarded PhD in Chemical Engineering from University of Sydney, Australia. Dr. Haque is an elected fellow of Australian Institute of Mining and Metallurgy, Australian Institute of Energy and the Institute of Materials, Minerals and Mining, UK. He was a professional engineer accredited by the Engineers Australia, a member of the Minerals, Materials and Metals Society, TMS USA, very prestigious society, and a director of board of Australasian Life Cycle Assessment Society. Dr. Haque, being a scientist, also takes an avid interest in teaching the students in academic and research universities. So, being an adjacent faculty, he coordinates undergraduate courses on minerals processing at Monash University, Australia, sustainability and life cycle assessment at Swinburne University in Australia, and he also offers lectures at RMIT University, Melbourne, and also runs workshops over a decade. And by that time, he has co-supervised 11 PhD students and 54 vacation scholarship projects. Currently, he supervises more than 5 PhD students at various Australian universities. Dr. Haque has published over 100 scholar publications in various refereed journals to his credit. He manages several high-level intergovernmental scientific collaborations and is the leader for the Memorandum of Understanding signing between large multiple organizations, government science agencies, ministries and universities. So with this, I welcome Dr. Nawshad Haque to our institute. Now I request the dignitaries, Dr. Nawshad Haque, our head of the department, Dr. Abhishek Kumar, the local GIAN coordinator, Professor G.P. Sahu, and the course coordinator, Professor Anuj Jain, to please be in the dais. Sir, please. Now, I request our volunteers, Salini, to please offer a flower bouquet to the foreign expert of this course, Dr. Nawshad Haque. Now I request Anupama, our another student volunteers, to please offer a flower bouquet to Dr. Abhishek Kumar, Head of Applied Mechanics Department. So, now I request Dr. Nawshad Haque to please share his thought with us.
Good afternoon, everyone, and thank you, Dr. Akshoy, for introducing me or about kind words about me. And it is really great privilege, and also I'm really grateful for your kind hospitality and inviting me for this life cycle assessment course. And obviously, we'll be talking the participants. I'm telling that next few days all about LCA, so I don't want to go there now. And you can see that that course, I think what I've been introduced to a lot of over the years, application of that life cycle assessment in various industry sectors I've applied. So it's not necessarily I have a lot to share, but some of the experiences over the next few days we'll be sharing. So, you know, globally, it's really interesting time, remarkable time, I would say. I did my PhD 20 years ago, chemical engineering, and started jobs, mainly my experience with R&D organizations. And I come from this part of the world. I grew up India, Bangladesh, kind of frontier near Kolkata. And I left, I was telling professors that I'm 52 years old, and 26 of my years of my old outside Bangladesh. So I left quite a while. I live in the West. Essentially, that's my home, adopted home, but I come from the East. And often I say when I go to this sort of event that, and actually I feel and I tell genuinely that I'm one of you. So one of the things that I would like to do over the years, that whatever I learned, and I came from quite modest background. I got educated in Western countries. I did my PhD. I did my master's from UK. So some of the experiences I got through my 20 years career, I thought, why don't I share with my, particularly younger people of my parts of the world, so the South Asia, India, Bangladesh. So India is not new to me. I'm not a stranger here. I'm coming here for the last 12 years, I think, various institutions. In the morning, I had a presentation at the department. I was telling that someone was telling me that you know a lot of Indian institutions. The reason is that I tried to, whenever I came on holidays or anything, I tried to see where are the problems. Can I contribute? That's my part I try to do. It's not that I'm saying I have done a lot, but I have tried, and I would like to hand this over to particularly younger students. And whenever someone asks for help, I try to do unconditionally within my capacity. So this is a start. Do not take these 5 days as forever thing, or that I say goodbye and that's it. It's kind of a start. I want to know you, you know me, and I am hoping for good times next 5 days. And whatever you learn or try to learn, if you enjoy that and if you try to feel it, that life cycle assessment is a kind of philosophy thinking. And I think I was having a last few days with Professor Jain that sustainability and globally, you know, all these societies has got good things, West and East, you name it, or you tell it, Western philosophy, Western way of thinking, Eastern way of thinking. Let's blend them together and get the best out of it and fuse them for the global goods. And that's I'm here for, and I hope that we all will have a good time, and looking forward to meet you all, know you all. And yeah, with that note, thanks a lot, Dr. Akshoy, and then thanks for helping me, and particularly the kind host, department head here. Thank you again, once again. Thank you all.
Thank you, Dr. Nawshad Haque, for your kind speech. We have received participants from various IITs, ISC, NITs, state universities and colleges. More than 32 participants are attending this course at present. So it is indeed a huge success for the course, and the coverage is wide. So I invite Professor G.P. Sahu, the local GIAN coordinator of our institute, to share his thoughts about this course and in general the GIAN program.
Hello, good afternoon to all present here. Thank you very much, Dr. Akshoy, for giving me this opportunity to talk before the audience present here. I'm thankful to Professor Nawshad Haque. I welcome you to this program, and thank you very much for sparing time and then agreeing to participate and then contribute for our GIAN program. Professor Jain, Professor Abhishek, Dr. Akshoy, Ranjan, Paul, Dr. Ajay, Bharti present here, and all my fellow colleagues present here, my dear students, the team member present here. Very good afternoon to all of you. I'll briefly tell you about the GIAN program, although all of you have gone through the website of Global Initiative Academic Network. So there the objective of GIAN program is not only teaching learning, okay, so we are assembling here with the expectation that foreign faculty is going to teach us in a current and emerging area. So that of course is one of the objective, but another important objective which Professor Haque has already mentioned about, that networking, okay, so we need to know each other, we need to connect with the people outside our country, and we need to know about what research, current and emerging area research going in this, especially the topic we are going to study here, sustainability, engineering, etc. So that's important thing. So objective is, threefold objective is there. We need to establish the network with the people in a particular domain. Okay, so here the domain is of course the course that you have registered in this area, who are the expert, and then what work being done, and we need to exchange. Okay, so it is going to be lifetime connecting, establishing the connectivity for the lifetime, that you have a common interest in the particular area you wish to do research, and here we have an expert who is authority in that particular area and may be able to contribute in a long term. Okay, and I'm very happy that Professor Nawshad has already mentioned about that. This is the start of the journey. It is not that we are going to have only 5 days program and after 5 days you get a receive certificate and then program is closed. Here it is just the starting point, and then we'll continue with. Okay, so so first objective is the networking, and then of course the course you are going to attend, you are going to develop specialization or the expertise in the area you have opted for, and further it has to be in the area of current and emerging. So it is expected that you are going to have the basic knowledge of the area, what area we are offering a course, and then beyond that point you need to build up. Okay, so it has to be necessarily has to be a current and emerging field where in Indian context less number of research has been done, or less immersed area, especially with respect to our continent. Okay, so with this I'm very happy that two of my colleagues, they have taken up this agenda, and they have formulated a course structure, and now today we are offering this course. About the GIAN, we started in the year 2016, and now it is an old program. Of course, we had bad time of poor time during COVID, but still during COVID also we could offer few programs through online mode. Okay, so we started in the year 2016, and I'm very happy to share that Applied Mechanics Department is pioneer, or first few programs were offered by Applied Mechanics Department. And also if you go by the number of programs offered in this institute, it is altogether 34 we have already completed, and this is the 35th program we are offering in the institute. But if you go by number of program offered by Applied Mechanics Department, I think it is 10th. It is 14th program. No, stand corrected. So this is the 14th program. So half of the program offered by Applied Mechanics is starting, and continuously they are contributing in terms of number of program organized. So it's a good number of program, that 14 number of program being offered. So if you consider all India level, so it is 2,163 number of programs already approved, out of which 1,700, that is 1,713 number of program already offered. So I'm talking about pan-India, all institutions who are offering GIAN program. So this is a big program, okay, and then amount involved or the faculty involved. They are state-of-art programs, and the authority, those who are expert in the area, we are inviting from the foreign or reputed institutions. Okay, so that way it is considered to be one of the very, very important program. Government of India, Ministry of Education is spending huge amount of money for organizing this program, and we must consider that it is one of the important program, flagship program of Government of India, and we need to get benefited out of it, fulfilling all the three agenda or the objective of the program. With this, few things about the participants. You are coming from different institution. That way, you are connected to your parent various institution. Okay, so that way, networking has to be in 3 levels. Networking, peer-to-peer networking is very, very important. So you are connecting here. So you need to establish exchange. It is going to be 4 hours program for 5 days. Every day 4 hours teaching will be there. But beyond that time, also you are going to interact. You get an opportunity to interact with the faculty present here in the department, visit all the facilities in the department. Of course, head of the department will facilitate in that respect. But my point is that networking is very, very important. Form a group. Like-minded people are here. You are interested in a particular area of research, so therefore networking at this level. You are getting network with the foreign faculty and the faculty present in the institute. So that also you need to strengthen the networking that you have. Okay, so it is interpersonal relationship or the human-to-human networking I'm talking about. Okay. And then further, it is going to be institute to institute networking. Okay, so your institute need to be connected with the institute from here Nawshad sir is. Okay, so Professor Nawshad is. So that way, no connectivity, and then country to country connectivity to be established. Okay, so that way, that's a important thing here, and must consider that it is just a starting point that we are starting here. Okay. So with this, I'm thankful to the foreign faculty again, Professor Nawshad Haque, for sparing time. I'm thankful to MNNIT and especially IIT Kharagpur, who is the nodal agency for this activity, and Ministry of Education is the funding agency for us, Ministry of Education, that Government of India. And all my team members who are participating and supporting this initiative, especially team members present here for the online, making this program available online through the live streaming. We have with us Amrendra, Vikas, Soumya, Darshan, Ankita, Akansha is also here, then Dhirendra and Sunil. And all the other members, I do not know the name of the team members supporting from the Applied Mechanics Department. I'm thankful to all of you. And my best wishes to all the participants, and thank you very much, the coordinators, for organizing this, and congratulations to the department. Thank you.
Thank you, Professor Sahu, for elaborating the activities of GIAN and the contribution of MNIT in this GIAN mission. So now I request our head of the department, Dr. Abhishek Kumar, to come and share some of his thoughts with us, especially the activities of our departments.
Thank you, Akshay. Good afternoon, everyone. I, on my behalf and on behalf of department, welcome you all in the institute, and special thanks to Professor Dr. Nawshad for sparing his valuable time and to travel all the way from Australia to here to take this subject, life assessment. So I'm very thankful to him. To brief about the department on the institute was established in 1961, and Department of Applied Mechanics was established in 1964 with the name Department of Applied Mechanics and Process Equipments. Our first PG program. We deal with PG and PhD only. We don't have this time any UG program. Our first PG program was started in 1967 with the name of Analysis and Design of Process Equipment, and in 2002 the name of the department changed to Department of Applied Mechanics. We are running 4 PG programs in Engineering, Mechanics and Design. Applied Mechanics, it was earlier known as. Second is Material Science and Engineering. Third, Fluids Engineering. And fourth, Biomedical Engineering. Now, looking to the need, we are going to start 2 UG program. First will be starting next year, that is in Mechanics and Computation Engineering, and thereafter in the next year we are going to start a course in Materials Engineering. So this department is one of the oldest department and is a multidisciplinary department, because the faculty here are of background from civil and mechanical engineering both, and Professor Jain is also from chemical background, so it's a blend of many engineers here in the department. And as far as GIAN is concerned, till now we have organized 13 GIAN courses, and this is the 14th one. I feel that these coming days will be very helpful for all the participants to understand the course in depth, and will be beneficial for all of us, right? So with this small words, I again welcome Professor Nawshad. I'm thankful to Akshay and Professor Jain, because he was the first, Professor Jain was the first in the department who initiated or started this GIAN course. So the first course of the institute was organized by Professor Jain, not only in department but also in the institute. So thank you all. Happy stay, happy learning. Jai Hind.
Thank you, Dr. Abhishek, for your speech. So this is the first GIAN program which we are organizing offline after the Corona COVID episode. So we have 7 more GIAN program which are approved by apex body of GIAN authority, which are in pipeline, and we are trying to organize it one by one in 2023. Now I request our head, Dr. Abhishek Kumar, to felicitate our ex-chief, our expert, foreign expert, Dr. Haque, with a shawl. So, energy and water are 2 important resources. Some countries have abundance of it. Many countries requires this energy and water. But whenever we use the energy or water, we have to use it sensibly. So that's why the importance of life cycle assessment to determine the water energy footprint is required. If we see the background of the participants, they are from science, they are from engineering, they are from management, but with one objective, to use the technologies so that we can maintain the sustainability, the sustainable use of energy and water. The participants are coming from various parts of country, different institutes, and at different levels, from undergraduates to postdoc levels, and some faculty members are also there from different institutes. So we are at the end of this inaugural ceremony. Now I request Professor Anuj Jain, who is also the course coordinator, to please share his thoughts and propose a vote of thanks.
The resource person for this program, Dr. Nawshad, my colleagues, participants, student volunteers, it's my honor and pleasure to propose this vote of thanks. Dr. Akshoy, who is the principal coordinator of this program, has given me this responsibility to propose this vote of thanks. And I would like to start with to acknowledge Dr. Nawshad Haque that he has very kindly accepted our invitation to travel such a long distance and conduct this program here and share his expertise with the participants here. We are really indebted to you, sir, for your kind traveling such a long distance and sharing your expertise with us. As you know that Dr. Nawshad Haque has experience as being the teacher. He's a researcher, and not just a researcher, he has been instrumental in converting various technologies which are being used today in different places in the world. And he is spearheading several new initiatives in hydrogen energy and others. That's really work is looking forward to in near future. So I'm very sure that his expertise and experience will definitely be of great use to all of us here. And personally, I'm looking forward to learn a lot from him in next 5 days. This GIAN program was envisaged by the IIT Kharagpur. And I really like to acknowledge that IIT Kharagpur who planned this program, wherein the faculties from all over the world were invited to India and had an opportunity to interact with the faculty in India and the various level of students in India. And they proposed a huge program, which you know already more than 2,000 programs are there. And each programs have several lakhs of expenditure. You can say it's crores of rupees, hundreds of crores of rupees government of India is spending on this program. And it is expected of us that when such a investment is made, that really comes out to a fruitful end and we really get benefit out of it. So I really acknowledge GIAN for IIT Kharagpur for planning this program and making it reality happen. And since our department and institute is also benefited, our department has 14 programs, institute has 34 programs. So we would like to acknowledge the GIAN and Ministry of Education, Government of India. Because of that, it has been possible. And we see the effect and benefit of it at our institute level and our participants also. We acknowledge the director of this institute, Dr. Professor R.S. Verma, who has been a source of inspiration for all us to conduct such kind of programs, and his guidance is really valuable to us. The local GIAN coordinator, Dr. Sahu, he is really a great instrument in organizing such programs. His helps are always available to us unconditionally and make this happen in a manner that it's possible just because of his support which we receive. We are also indebted to head of the department, Dr. Abhishek Kumar, who is really inspiration for all of us. He encouraged all of us, and we are working under his great leadership to do some little work which we are able to do. I am also grateful to all the student volunteers who really taken the initiative to take all the load, and you must be interacting with our students through emails, and you know how meticulously they have been organizing the things. You might have been receiving the mails, communication, and all that. So this is our endeavor to train our student not in technically, but to be a good citizen and the person of responsibility in the society. And that they have really demonstrated in a very nice manner. I'm really proud of them. And I really thank them for their all efforts. I don't remember name of all of them. The Shalini, Anil, Devesh, there are MTech students are there. Aditya, Anupama, okay? So some of them I can see the faces, but there are many behind the scene who are really working very well. I'm also indebted to Amresh and his team, Amrendra and his team. Actually, I don't remember all of them, or few are new to me, but they have been really supporting this program, and its online telecast is possible because of this team. So I really thank them for their efforts. There are many faces behind the scene within the department, the colleagues, the staff who has helped us at various levels to make this happen. And I'm also indebted to my colleague and principal coordinator of this program, Dr. Akshoy Ranjan Paul, okay, who has given me an opportunity to be part of this program, and he's really doing all the work. I'm just there for the namesake, okay? So the whole credit goes to him for organizing this program. And last but not the least, the participants. The success of program is not what we are doing. Success of program is just because the participants. If the participants are not there, whatever best we do has no meaning. Okay, so I'm really happy to see that there are good number of participants from various disciplines, various levels, various places in India. So that gives a lot of satisfaction for us to organizing such kind of activity when we get such kind of a response from the participants. And I hope you will have a nice time at MNNIT. And as already pointed out, the program is designed in such a way that you are not engaged full time since morning till evening. Okay, you see, it's only half a day engagement. We expect you to spend rest of the time in moving around MNNIT, seeing the facilities here, interacting with the facilities here, and interacting among yourselves. So the idea is when you go from here, you have enough exposure and networking which you can cherish on a long-term basis. Okay, so please utilize this time for all these purposes. So we look forward that you have a comfortable time. In case you have any difficulties, feel free to interact us. And the volunteers, the student volunteers are there. I hope by the time you know most of them. So feel free to, if in case of any need. Okay, and I wish you a comfortable stay at MNNIT. And I hope this program will be beneficial to you in a long term. And remain connected even after leaving this program. Okay, we look forward to have a long-term relationship. That is what is envisaged in this program. Okay, so networking is an essential component of this program. So thank you very much. Let's not give chance to Professor Dr. Nawshad to start his program, and let us learn from him. Thank you very much.
Thank you, Professor Jain, for your Thanksgiving speech. So we are at the fag end of this program. So it would be nice if you could all raise for the National Anthem of India. Salini, please come. Call Anupama. And whoever likes to sing the National Anthem, please. Please, you can come here, join us. Anybody? Please. You lead and we'll.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Thank you, everybody. Now I request you all to please join us for refreshment, and we'll start our course, the lecture 1, just after refreshments in next 20 minutes.
welcome in the course, and I think end of this course if you can tell what is LCA is, and you can now, I guess that's very important. So I think I'm sitting now, maybe I will stand soon. So as you know that in any course the participants are the heart of it, and what you get out of it, that's another importance for the presenter. So what I want to make sure it is a good learning outcome you have got, and as we discussed in the inauguration session that it's a long term relationship. So I know we have got Professor Jain as a kind of our on top of our head as a guardian here, so which I'm really grateful to you, Professor, and obviously you all, we learn from each other, and it's always two-way learning. It's not that I know everything, it has to be interactive, and I want to set up some I guess expectations. One is that you have to participate, you have to contribute, and either willingly, whenever I say something, ask something, please contribute. I don't know anything about, or not anything, but a lot of things about India, what you know, you on the ground. The other thing is that I think I'm not sure, initially we should start with, we have talked about ourselves, particularly myself I've spoken about, maybe I'll tell a bit more, and obviously next 5 days I'll be telling about my experiences. By the way, are you following me, are you listening okay in the back, everyone? All right, okay, and online hopefully they are, if they're not, please communicate with our technical people, so they will help you out. So what I want to start with, maybe from this side of the room, that I mean I'm not saying you have to stand, but good if you can stand so you all can see each other. You tell your name, who you are, where you are from, institution and maybe city, and what you one thing you want to get out of this course. So that's gives me a bit of perspective. So I think without doing it, and then once we finish that exercise, I'll go online. People online is participants. They finish it, and I'll go to my lecture. Is that okay? And do you have any question before we start? Anyone has got any comment or question? Otherwise, I'll start with. By the way, you have got everything you needed from the organizer, I guess, from NMNIT. You have got the. At the moment, anyone needs anything, please hands up, or otherwise we can start. So you have got everything required information, what we are going to do the course. So this, after this event, we will have a lecture, basically, well, what I want to get out of it, some foundation, some lecture, but you will do a lot of homework, a lot of things you have to do yourself, hands on. So let's move into that one, and welcome again, once again. So I think I should start from that back, isn't it? So I think front row our colleagues, I believe, but it's still good to introduce yourself maybe, and we start. Okay, let me introduce first myself. I'm Nawshad Haque, obviously you know that one. I'm the course presenter. We have got Dr. Akshoy, will help me out to run this course. So I'll be probably the main person in terms of delivering the technical part of this course, but I'll be assisted by colleagues here. I am, as I think I've been introduced, I work for CSIRO. I'll tell more about that. So maybe you can start if you want, if you don't mind. Yeah.
Sir, I am Abhishek Kundu. I am the faculty of Applied Mechanics Department, and my specialized area is computational fluid dynamics. I am working on computational fluid dynamics.
Thanks a lot.
From CSIRO.
CSIRO, thank you. Nice to know you. Nice to know, Doctor. And
Sir, myself, Vinesha Pal. I am faculty in the Department of Mechanical Engineering, and my area of research is thermal engineering, mainly in renewable energy and also in IC engine field.
thank you a lot.
I am H.K. Pawar, working in Department of Applied Mechanics. My area of research is electroacoustic transducer, acoustic, sound and material.
Thanks a lot, Professor Jain. You don't need, but you can.
I'm faculty in the Department of Applied Mechanics, and I try to do something little bit in CFD.
Thanks a lot, Professor. Thank you. Thank you. So, and now we are starting with the participants, I believe, right? Yeah. So, please.
Everybody, my name is Ranjan. I'm from Himachal Pradesh, and I'm currently pursuing my MTech from America. And through this course, I wish to gain deeper knowledge about LCA and like the products and services, and make use of it in my future studies.
Thank you. Thank you very much. I hope we'll get there. Then next, please.
Good afternoon, everyone. My name is Manish Kumar. I am second year physics and how they impact our personal behavior and how they impact our environment system.
Thank you so much. Next, please. Thank you. Thank you so much. Actually, I cannot speak English. My apology. I'm from Hindi. English, obviously, I can manage. It's not my language, though, second language. So, obviously, we all would be some language issues. No problem. You can speak in Hindi. I understand. समझ सकती है, बात नहीं कर सकती है. So, but also the next one, please. Yeah, but English is fine anyway.
Good evening to all of you. So my name is Satyajit Manode. I'm a third year PhD student at MNIT Allahabad, working on a life cycle assessment of thermal power engineering, in which I'm actually dealing with the life cycle assessment of means energy and water footprint of thermal powers. Or means we are collecting data and analyzing, and that comparing with that of the photovoltaic or renewable energies. And this will be means it is my topic only. So.
Thanks a lot. Thanks. Welcome. And I think maybe mic is not working. Can you try again, or some next one probably? Is that mic working? Do you think? Oh, it's for online. Okay. All right. Okay. All right. That's fine. All good. Okay. The next one, please.
Good afternoon, everyone. So I'm Rohit Gehlot. I am from Rajasthan. I am pursuing my PhD from IIT Roorkee. Sorry, I took name of IIT Gandhinagar. I did masters from there. So my research, I'm working on recovery of rare earth elements from primary and secondary resources, basically from electronic waste. So my expectation from this course is that I will be able to learn various softwares, and it will help enhance my project like Casima Pro or Gabi software.
Thank you. Thanks a lot. Thank you. Maybe go that way, and then on the other side. Maybe. Yep,
my name is Anshul Goyal. I am from Delhi, and I am currently pursuing MSc from NIT Rourkela, and my topic is how fog is associated with the visibility. I hope this course will, I can gain some knowledge and get some knowledge about the software CIMA Pro.
Thank you. Thank you. Hope we'll do something.
Hello sir, hello everyone. I am Shivam Saxena from NIT Rourkela, pursuing MTech in Atmospheric and Ocean Science. Currently I am working on project, LULC project, like evolution of urbanization and its impact on heat. Looking forward to gain some knowledge about LCA and its application in carbon footprint and all things.
Thank you.
Good afternoon everyone. My name is Rohit Gupta. I am from Lucknow. I am pursuing a PhD from this institute, MNIT Allahabad, and I am doing PhD in energy sector. And I want to explore some use of CFD in energy, and want to explore life cycle assessment of various components that can be used in an energy sector.
Thank you. Thanks. Next, please.
Good afternoon, sir. Good afternoon, everyone. My name is Mishma Stanislaus. I'm a research scientist at Indian Institute of Science, Bangalore. So we are currently working on biomass to convert it via gasification technology to produce hydrogen. So I guess we have a lot of in common there. But and we have established life cycle assessment in the feedstock side of it. But the process we are still, making an attempt to do so. So I'm hoping this course will help me and my team accomplish that.
Sure. Thank you. Hopefully, let's see. Thanks. Welcome. Yeah.
Hello everyone. I am Dr. Kishan Phuse, Assistant Professor in Pandit Dindayal Energy University, Gandhinagar, Gujarat. I did my PhD in solid state welding, particularly friction stir welding area. Would like to know how to use LCA in welding in this workshop.
Thank you. Thanks. Hopefully, we'll cover some of those.
Hello everyone. I am Ravi from ISER Mohali. I am pursuing my PhD on developing an integrated technology based on microbial fuel cells and hydroponics for the management of wastewater from a house. So I want to do, from here I want to have hands on the LCA and I will apply that LCA for my technology.
Fantastic. Thanks. Good. Application is very important. Thanks. Next one, please.
Good afternoon, sir. Good afternoon, everyone. I am Srivatsan from Tamil Nadu. I have completed my PhD in environmental engineering. I am looking for careers in the sustainability and environmental sector. I have also done a course recently on sustainability reporting, and I also want to know how water and energy footprinting can be done through LCA.
Thank you. That's hopefully we'll be getting there, and there are shortage of professionals in this area. Please. Yeah.
Yeah. Good evening, everyone. I'm Ankita K. Vishnath. I'm from Kerala. I'm currently working as a research associate at IIT Palakkad. I have done my BTech project in life cycle assessment of building materials, and currently I'm working for another project in IIT Palakkad, wherein I have to deal with the water footprint assessment. So looking forward to learning that from you, sir.
Thank you. Thanks.
Hi sir, I am Sahu Kumasa. I am from West Bengal and Durgapur. Well, currently I am in PhD second year, and I am working in steel making using biomass and also filtration of impurities through hydrogen plasma arc welding. And yeah, I want to know the secrets of the LCA using the environmental impacts of the environment.
So thanks a lot, Avash, and welcome here. And Avash looked after us. I was in Durgapur 2 weeks ago or 3 weeks ago. So anyway, good to see you here, and I hope we will get something out of it. Thanks.
Good evening, everyone. I am Dr. Sunita, Assistant Professor in Civil Engineering Department, Deenbandhu Choturam University, Murthal, Sonipat. And my specialization is environmental engineering, and I'm looking for the LCA of concrete using some software like SIMA Pro or Gopi.
Thank you. Thanks. We'll cover some software aspect. Yeah.
Hello, sir. Myself Akshoy Gupta. I am doing PhD from this institute in NIT Allahabad. I am working in the area of carbon capture and storage from thermal power plants and doing LCA and techno-economic analysis in that area.
Thank you.
Hello sir, myself Devesh Singh. I am pursuing PhD at this institute, NIT Allahabad. My research area is renewable energy, especially for ocean energy. And I am working on a device to extract the energy through waves. And looking forward to explore the LCA to check the environmental impact. How we can, if we explore we put on a device on ocean, then what is the environmental impact? So
sounds very good.
So
Thanks.
I'm looking forward to explore the same.
Thanks. Exciting project sounds like. Yep.
Good evening, everyone. I am Shalini Verma. I am pursuing PhD from MNIT Allahabad, and my broad area is wind energy, and I am currently working on CFD analysis of horizontal axis wind turbine as well as life cycle assessment. And this course can help me gain more knowledge about this topic and also for a better understanding.
Thanks a lot, Shalini, and good to have you here. And you know probably Shalini from correspondence, I guess. And I encourage you to look at Shalini's paper we published in online. I think, yeah, I'll be using that a bit of an example anyway, and Shalini can speak later also. Yep, please. I think we missed some of those. I think, is that okay? Or everyone participant, or did we miss anyone here? Maybe we can finish that side and then come this side.
Hello everyone. I am Anil Kumar Maurya, PhD student in Applied Mechanics Department in NIT Allahabad. I am doing my research in friction stir building. I am a volunteer of this course. I hope I'll learn some new areas from this course.
He is working with Dr. Sundar.
I see. Okay. Thank you. Thanks a lot. Yep. Anyone else here?
Good afternoon, sir. Good afternoon, everyone. My name is Aarti Chokse. I'm Assistant Professor of Civil Engineering Department, Deenbandhu Choturam University, Murthal. Basically, I am doing my research in supplementary cementitious material, and we are doing some work in precast and cast in situ fabrication also, and there we are using LCA methods for basically to determine the footprint, carbon footprint, or energy footprint of these two technologies as whole. So
thank you,
very good course for us because this is new topic and also it's very demanding topic in demand basically.
Thank you, ma'am.
We hope that we can learn and use that knowledge in our research and everything Thank you, sir, for
Sure.
organizing this course and
Sure.
being expert here.
No, thanks. Thank you. Thank my pleasure. Hopefully, we'll share some. And thanks the photographer. You are covering a lot. And anyway, so we can move to the participants back.
Good afternoon, sir, and good afternoon, everyone. My name is Tej. I'm from Hospital and Healthcare Management. I work as assistant professor at the National Cancer Institute, Jhajjar, Haryana. Broadly, my area of interest is LCA and sustainability with respect to hospitals like the built environment and medical devices, and also how to make hospitals energy efficient.
Thank you. Thank you so much.
Good afternoon, sir. Good afternoon, everyone. I am Aditya Yadav from MNIT. I am pursuing MTech here, and I am working on the thermal management of batteries in electrical vehicles. So, from this course, I would like to implement a LCA concept in my battery and electrical vehicle.
Thank you.
Good afternoon, sir. Good afternoon, everyone. Myself, Pushkal Jaiswal. I am pursuing MTech second year from MNIT Allahabad, and my thesis topic is related to LCA as e-waste. So, from this course, I would like to learn more about LCA.
Thank you so much.
Good afternoon, sir. Good afternoon, everyone. My name is Anupma Gupta, and I am from MNIT Allahabad. My thesis topic is hydrogen transportation through pipeline, blending with natural gas.
That's interesting area. Thank you. Looking forward to talk to you more.
Good afternoon, sir. I am Vikas Yadav from PAC Chandigarh, and currently I am pursuing PhD on green composites, and I want to learn LCA for my composites to implement it on my composites.
Thank you. Thanks so much.
Good afternoon, everyone. I am Shweta Singh. I am pursuing my PhD from Indian Institute of Technology, Mandi, and I wish to apply LCA for the upcoming solar technologies, especially for the perovskite solar cell. So that's why I want to learn it from you.
Fantastic. Thanks. Hope welcome here.
Namaste, sir. My name is Santan Chaurasia. I am from NIT Jalandhar, and currently I am working on sustainable manufacturing, and that right now I am trying to assessing the effect of cutting fluid and cutting energy on the human health, ecosystem and resources. Along with that, I am working on also a metal matrix composite. In that, with local industry collaboration, we are working on recycling aluminium.
Thank you. Thank you.
Good afternoon, sir. Good afternoon, everyone. My name is Rohit Kumar Slotra. I'm a third year PhD scholar from NIT Jalandhar itself. I'm currently working on a life cycle assessment of agriculture product, especially on inorganic or organic potatoes. In the upcoming harvesting season, I'm going to work on a rice itself. So through this course, I'm able to determination of water footprint of rices.
Thank you. Thanks a lot.
Good afternoon, sir. Good afternoon to all. My name is Prashant Kumar, and I am a PhD scholar from Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. And basically, I am from textile background, and my topic is related with recycled polyester. And I want to, through this course, I want to know how to make this polyester, recyclable polyester, more sustainable products in textile area.
Thank you. Thank you so much. Welcome.
My name is Janil, and I am research scholar in civil engineering department in Dinbandhu Choturam University of Science and Technology, Murthal, Sonipat. My area of research is life cycle assessment of interlocking paver block concrete by using industrial wear. And I want to learn about LCA framework, basically inventory analysis and impact assessment by using softwares.
Thank you. Yes.
Good afternoon, everyone. Myself Devanshu Sikarwar. I'm currently pursuing my PhD from IIT Delhi. I'm a first year student. I intend to work on biohydrogen production, mainly using a hybrid system involving bioelectrochemical systems or microalgae. And as the last objective of my PhD, I want to do sustainability study. For that, I need to learn life cycle assessment.
Thank you. Thanks. Welcome to the course.
Hello, sir. Hello, everyone. My name is Abhinav Devangan. I am pursuing my PhD from IIT Delhi. My topic is resilience of underground infrastructure, and I am here for learning LCA to apply LCA in tunneling infrastructure. Thank you.
Thanks a lot. Thanks. Anyone left here? Or otherwise online, can we unmute them and they can tell or not? How that works?
It's not from it's a one way.
One way. Okay, that's fine. Then in that case, we can leave that. And I think looks like we just sang our national anthem Jana Gana Mana Adhinayaka Jaya Hai Bharata Bhagya Vidhata. And they are, what is that, Binda, Himachala, all these states name, isn't it? Most major states. So looks like all India is presented here. So anyway, Binda, Himachala, mountain names, and also some Bongo, Utkala, some of the old names of the states, I guess, or the sort of regions and people they are here. Yeah, I think, and also one other thing is also mixture. We have got students, we have got colleagues, we have got academics, we have got researchers, consultants. Some of them have a lot of knowledge, some of them probably early. It's good to be in, and I want to learn from you. That's really good to be in that spot. So I think before we start, and it's good that Professor Jain and others also we stress that the networking. I hope when your other students talked, you probably listened, and at least you know you can catch up. Unfortunately, I'm not very good at names, so I will probably mix up. But if I just introduce me whenever your name particularly, so I can remember your names next time. So I think let's move on. So I'm hoping that will work okay. And you can see that one we are talking about sustainability engineering. So you remember science engineering, obviously we say engineering is the application of science. I sort of started my career as a science background, then engineering, work as a scientist. I'm not an academic, you can probably tell me, and you will see a few days that, but I teach, I love to teach, but on the other hand, at the end of the day, I love science and using science for development. That's my goal. So and application is the key thing. We in CSIRO, I mean I will talk obviously a little bit more. We say solving the greatest challenges through innovation. So through innovative science and technology. So we are trained to apply. And by the way, I think in the morning I had a presentation I told about. But by the way, anyway, here put your hands up. How many you heard about CSIRO, the name? I believe none. What about CSIR in India? You heard because we have colleagues here, isn't it? You are representing which organization? ISC, is that CSIRO lab or no? That's an institution. Is there anyone from CSIRO? Which one is that? That's in Mysore, okay? Food technology. We had one other colleague or not? That's only one maybe. Anyway, so there are, I know. So can you tell about CSIR? What is CSIR in India?
Basically, CSIR lab covers transdisciplinary research from across multiple domains. Has several sister CSIR labs where different disciplines of domains research is pursued across.
Basically, we do science and technology and research, technology research, R&D, isn't it? Research and development. So it is like Australian CSIR, we call it CSIRO. I think all these British, when they left or came in various countries, in South Africa they call it CSIR. In Bangladesh, for example, it called BCSIR. In Pakistan, they call it PCSIR, Council of Scientific and Industrial Research. We call it CSIRO in Australia. Commonwealth Scientific Industrial Research Organization. So in Commonwealth in Australia, anything like your central government, we call it Commonwealth government. So basically we are Commonwealth government employee, we get funding from Commonwealth government, and we are liable to our Minister for Science and Technology. In Australia it's called DST, kind of your equivalent. So I don't know, I think in CSIRO we do scientific research, but as I said, we train to do application, applied research. Anything has got application, we do research. By the way, you have used Wi-Fi. Now there is no way you can you cannot put your hands up. So you have used Wi-Fi, right? So I would recommend Google Wi-Fi and CSIRO, because that Wi-Fi was invented by CSIRO, and it's a really remarkable invention, isn't it? It changed our life, kind of business, everything. Trillions of dollars is generated. Although I am not in that business, but I don't know about Wi-Fi at all. But I know some of our scientists. It's called CAS, CSIRO Astronomy and Space Research in Canberra. So they used to transfer data in the 90s. So that's how Wi-Fi algorithm developed, and it's one of the algorithm, I guess, became the patent for Wi-Fi technology. So any devices like say Microsoft used to put in a device, they used to give us $3-4. So we got, I don't know, $1 billion from Wi-Fi technology as a royalty. But it's not a big mass. I mean, because it's a trillions of dollar business it's created. So sometimes I show you that who is our chief executive, he said that we need to get more IP. But if you say Wi-Fi was very expensive technology, it would not be implemented elsewhere. I think that's a good thing. It didn't earn a lot of money. And sometimes I think research should be for public goods. Because my career in the public means government R&D sector, and I think that's I favor. I mean, it's not I'm against business.
because business gives a lot of money and everything else, but always I feel global goods, that's what we do for. So I think we had a textile background. Anyone? So LCA, you can see that a T-shirt. So you can do on LCA on jackets. And apparently the cotton has a lot of impact on overall carbon footprint. Obviously there is a lot of footprints, and we call it LCA, life cycle assessment. We'll talk these things next few days, and it's a fascinating really to go through that journey where things started. So that's life cycle concepts comes in. Although I put that website, it's not, I don't use that much, but I think I have got other one. You can Google my name and you can see some of our work obviously. So I think let's talk about what's this course about. Who I am talked to about that, what is my credibility, obviously motivations, your motivations and also my motivations, why I am doing this kind of thing. As I said, I like to share my knowledge to others. I mean, often we make fun that if we say somebody is older, I'm an older person, go to the grave, knowledge does not go to the grave. So it's better to transmit someone that will stay alive or be useful. What will be the focus of this course? And obviously we have got colleagues who are doing it, and expectations from both. So I expect you certain ground rules, I believe. I think one of the thing I learned, what we do, last 20 years in my career, whatever I've been given, I tried to do that well, and that's I learned from one of my mentor. And you need to have a mentor, which is good thing. We have got Professor Jain here. Academics like Professor Jain has contributed a lot in the society, and that's the rule, that you have to be on time. You focus on this one, you do that things, that's the important thing to do that point in time. You have got phones coming, forget about that. That will somebody, if that really phone is important, they will call you back. So don't worry about phones, anything like that. Give your full focus. And Professor said that government is spending crores of dollar or rupee here, and that rupee coming from normal ordinary people paying tax, and taxes income. So that's, we have got a big obligation really. So try to use it, give it your full, and then get out of it, and it will be helping you, prepare you for the future, I believe. And what next? Obviously I said it is a long-term relationship. Let's come into. Okay, so far so good. Any question from the back? Are you following what I'm saying, everyone? Okay, and obviously if you don't participate, then I will probably put pointing to you, please contribute or please tell. So please be careful with that. It's not examination, and if you don't tell, I will not mind, or I will not be offended. And also there will be exam, but anyway, exam, forget about that. I don't think that will be hard exam, I believe, but anyway, that's at least be attentive, and that's my expectation. I think I shouldn't probably focus on this at all, but at least a nice picture, nice photo, isn't it? So in CSIRO, it's called a Faces of CSIRO program in 2006, and 2016, one of my colleagues said it's $1 million photo. You will show it everyone to every time. I said, why not? So what they say, because in CSIRO we do research, obviously we are scientists, so they had a program that what do you do outside research? Obviously 5 days will be, you have to basically take me, I'll be sharing what I do outside research, what I like to do. So that was the part of that, and there was a big photographer came one afternoon, or even I cannot remember, one morning probably, blocked for that. I had to pose various ways like a film star. So I never did acting, and I'm not good at that. So anyway, so that photo came out of that. So I think we have all told, I'm probably 20 years in Australia doing research. I love to work with PhD students. Not many scientists, there are scientists, they do research and development. I like a little bit more than that, particularly engagement with the universities. In my career, I have completed so far 54 undergraduate student vacation scholarship program, that what is called in Australia. So what we do, we bring the students 3 months, we give them stipend, and each project is about $50,000 if we add every cost. So we give them probably $10,000 stipend, some other things, and etc. So that way 2 students are there and they are communicating with me. So every year I take 3-4 students. So 15 years, maybe more some of the time, some of the years I took. So I love that, and those students became PhD because I test them 3 months, so how they're good, and then give them a scholarship probably for a PhD. And if they do well, okay, employ them in my team, become a team member, postdoc maybe, and then become a scientist. That's the typical kind of a route. Nowadays, more PhD than the position available. So, there is a bit of competition, but still that's broadly that's the way to go. I work with many universities too. Anyway, so that's yeah, I think I shouldn't dwell too much. So, I was born in this part of the world, here somewhere probably, that's near Calcutta, maybe 60 kilometer up north, and this is my photo obviously. My son, when I visited Bangladesh quite a while ago, although he visited recently too, he was now he is 20-year-old. He is a civil engineering student. He is in second year, next year starting. And in Australia, its life is pretty easy, I would say. I was asking him, what you are doing these days, holiday, because university stopped in November, I think they finish it, and start again in March or February, and this time they have nothing to do. So he's working in a shop for, as a shelving assistant. So put the things, stuff on the shelf and get some money. I said, good, save some, and you can, what do you want to do with this money? You want to go to USA or somewhere, some countries. That's the students do. He's helping his school, the teachers. So it's kind of available, and that gives the students to get confidence and also work and earn. So he's quite older now, and it is my father with me. My father is now 80-year-old. Actually, I saw him. He's doing well still, and he lives in that part of the country. So I sometimes I ask my students that what's special about this place, and they say this and that, India obviously, but this is a fascinating place, fascinating land, where they come from. And I see in the West a lot of interest for Indian philosophy. And Professor, we are talking about sustainability. Actually, root of sustainability in the East, in India, and that's now we are getting taught by Europeans or others that it is sustainability LCA that started here. So I just shared some of the analogies, some of the things I'll bring probably here too. Some of the photos, I think I feel like I'm still 18 years, at least in my mind, but I say I'm getting older. I know this is my college and university. Actually, my son, I took him whenever I go to university or a holiday in Bangladesh particularly, I give a course like this. And 2012, I think that I started probably giving that course, and it's now 10 years plus, I believe. At least 10 students got career in LCA in various parts of the world they work. I really get, I said this was started as I went on a holiday, what do you want to do? You want to arrange a course? I will give it. And then eco-invent. One guy they keep communicating with me anyway, like that's why I'm saying that do not take these 5 days as a forever thing. So he works for a company called eco-invent. We talk about that. Eco-invent is a big database, and he did, if you look at the eco-invent Indian electricity sort of database, he did that one. His name is Noor Muhammad, you can Google him, and he worked for, still he's working for eco-invent. Another, his name is Nazmul Hussain. He did pass that course and didn't know anything about LCA. He was doing environmental science. Did that course, then he did a master's in Netherlands. He's got an LCA scholarship. Then he got a scholarship at the University of Queensland, finished PhD. I think last year he finished or maybe submitted. He's now a scientist in CSIRO. So that's a really great outcome. I see that one. Somebody come from there and now a scientist, and he does very good work in agricultural LCA. So, but anyway, so that's on top of that. What do? I travel. I mean, I like to travel, to be honest, but on the other hand, I used to, not as much as, because before COVID it happened, and you can see all the way to Hollywood probably, but not for acting obviously, as you can remember. I like work and travel, to do something at the same time you travel. So I think this is in Korea, very beautiful place where I think I have been, I don't know, countless time because of life cycle assessment and also the work with electronic waste recycling. Somebody told her he's doing electronic waste, that's right. So it's a big topic and really hot topic again. All we have got, I have got 2 phones here. Everybody has got, I don't know, I ask how many phones you have used. Everybody say, oh, 8, 9. Even nowadays 25-year-old, older and younger, they say that I have used 10 phones, 15 phones. So where are they? Here and there in the drawer or somewhere. We have a certain obligation to do what we can do about it. Yeah. By the way, in the back, how many phones, Shalini, you have used? 1? Or, oh, that's a good job. And how about anyone else in the back? Who is the used highest amount of phones in your lifetime so far? Students. And how many is that? How many phones you have used? You? Yeah. 1? Anyone else? What about you? How many? 3? Okay. Any number? Any other number? It's a bigger number a bit I am looking for. 5. So see that one. So people maybe I don't know. I think if I ask more, I heard the highest one is 25. One of the student used. I don't know how he got that money, but maybe he was recycling. So but where are they? And we need to look at that. So obviously Agra, when I that is the first and a second, I think third time I came in Australia. There was an International Mineral Processing Congress in Delhi. Someone from Delhi, isn't it? Yeah. So we stayed in Ashoka hotel. We had, I don't know, maybe 12 people came from Australia. So we had a big trip to Agra. That is the time, I think. And IMPC, it's called Olympic Games of Mineral Processing. So India tried a lot. It's like again bidding process. So somehow got that year 2012. Tata, one of the guy, Mr. Pradeep, he sort of was behind that. And obviously our CSIRO colleagues is still Dr. Ralph Holmes is the chairperson for that. And another gentleman is Dr. Robin Batterham, who is kind of Indian. He was a chief scientist. So he does a lot of Indian related work. Obviously that's in Bangladesh, and that's again like yesterday I was in Sarnath. That's 800-year Buddhist monastery in Bangladesh, one of the oldest monastery. Obviously I said, oh, that's one of the learning. If you go to anyone from Eastern, and I think Avash, you are from Kolkata, Avash or Durgapur. Have you been to tomb of Mother Teresa, Missionaries of Charity, isn't it? So seeking happiness in materials thing is a sure way of being unhappy. I mean that's a nice, I always remember that, but on the other hand it's hard to implement. I was in Sarnath with Professor and also Benares. A lot of things soaked with experience, and you know it's a kind of different environment. I was trying to concentrate or disconnect myself for some time that okay I want to contemplate, but in the morning I was thinking
Happiness in material things
is a sure. Obviously that's another important, and critical energy and also hydrogen energy. But in the morning, you know, when we were sleeping in Sarnath, I was thinking in the morning, what about the hot water? So you know that you need or not necessarily luxury, I would say essentials. And then I was thinking about those energy, where it is coming from. And in India, different country has got different energy issues, and we help governments. Actually, I've got an advisory role in various government institutions, and I know how critical. And always the question is that where do you get energy from in the 10 years down the track or 20 years down the track? And obviously, LCA can help some of those answers, and that's I do. As I said, in India, I'm not a stranger. Coal mine in the, that's a, what's that called, place called near Ramagundam. Have you heard of that? Or near Hyderabad, isn't it, Professor? That's Singarali Ramagundam. Yeah, so that's right. So that's, I looked at this coal seam. That's quite, I think, small bits coal, basically a lot of overburden. In Australia, not like that. We just dig, I don't know, 10 meter, you get very good quality, high quality coal, and that's why I think we control Australia 2/3 of world coal market, and we send to India. And also with one of the trade minister, our Stephen Chobo, I came here. There's another minister. Actually, these are the previous government had changed there. So I came as a part of ministerial delegation selected for India, and that's the reason. This is in Kolkata again, Hindustan Copper. So, but anyway, so these are the things I'm not going to show too much, but in Bangladesh I help the government as I mean thing is that whatever I do, I always intention how I can utilize that for my own country or own continent, and that's we had kind of DFAT, government funded program to train Australian government officials in Afghanistan, and that's Professor how I met Dr. Akshoy there. The 2 bases we have done in Kolkata. That's RMIT University. And what do I do in my other role as when I'm not working as a scientist? So I do volunteering, and volunteering is I think anyone, if you obviously you need a job, you need a real profession, proper work for living, you earn money, you live, but also keep always volunteering in your mind. It will satisfy you, will help you to go, and actually that gives me fuel to run the other business. You need to earn, but you need some fuel to run, and volunteering gives that one. So as in my voluntary role, I am the president for the Bengali language school in Melbourne. That's the oldest school in Australia, one of the oldest school, and that's how this is the premier of Victoria, which is equivalent to Mamata Banerjee, say in West Bengal, kind of that. So we had a lot of, that's my son and myself, so we do a lot of community thing, and then obviously the connected with the politicians there. So Yeah, if you say faces of CSIRO, what do we do outside? And he's the member of the parliament in Australian government, Julian Hill, a very good supporter of multiculturalism. And another thing we say that in Australia, multiculturalism, that when you people come from various countries and you work together to help the country. And I said, this is not a thing in India. I mean, it's a, you know, how we live together, various languages, various ethnicity, various religion, and we love to work together, live together for a long time. And that's people, world should learn from that model rather than inventing that. So I think that's again Chile, India, Dhanbad, that's our long friends. I think I should probably stop this here, but the reason is I'm saying that this travel or this work gives you meet people and learn people, and the way I go there to learn, and that's how I enrich my own experience and I share with you, so you learn also that one, and I want to learn from you too, so that to increase and improve further. This is our chief executive, Dr. Larry Marshall. Actually he is an Australian and he was in Silicon Valley for a long time and set up many companies. Some of them didn't well, some of them did very well. So he was kind of he's running that our organization. So we have got a lot of research activities. I've got a lot of PhD students. Anyway, by the way, who has what I would say in terms of metals, tell me, I just guess, life cycle impact of metals, which one do you think would be highest? Say kilogram of CO2, because they will be using this unit a lot. So in the back maybe I want to answer someone. Kilogram of CO2 per kilogram metal or ton of CO2 per ton of metal, if I say that one, which metal would be the highest, do you think? Any idea? Steel? Okay, I got an answer, is steel. What about others in our back, other side? What would be Avash? What do you think? Steel. So I'm talking about specific footprint. So ton of CO2 per ton of metal. Okay. Rare earth metals would be high. Yep, that's a good answer. Anyone else? Lithium. Yes. Oh, why do you think steel? Those people have said steel. Any justification or just guessed? Do you know number, by the way? Steel, can anyone give me a number? Steel would be, give a number, anyone just guess. Ton of CO2 per ton of steel making, say made steel. What would be that? Avash, any idea? Or anyone else? Shalini, any idea? What is the ton of CO2 produced or emitted to make 1 ton of steel? No idea? Anyone else? Google it maybe. Anyway, so you don't have the phone maybe with you. Steel is 2 generally, plus minus, okay. 2 ton of CO2 per ton of steel, okay. Now if I talk about gold, so that's Fosterville gold mine, that's I know well because one of the work we did. Gold is said 28,000 kilogram or 28 ton or 32 ton depending on the what ore you are talking about. So 32 ton of CO2 per kilogram of gold. You understand what? So which one is the highest, steel or gold? Obviously gold, many times highest. And I think I'll share some thoughts that one of my student did, PhD student obviously. Actually that's here, Stephen Nordby. He's very good, you can Google him. He's one of the renowned LC experts now and really fascinated. I brought Stephen, like I told you that vacation scholarship, he came as second year student, third year student, did a very good publication. For a third year student, I was really amazed to see him. He did copper LCA, okay, and then he came as I gave him a scholarship, did a PhD and did the gold LCA. I think how we are going with time anyway, so that's probably we have a bit of time. So, so that's he calculated, it's called, that slide is quite, you can Google it also, you might find it, price of love. So those who are married obviously use gold rings. So one gold ring has 3 grams of gold, okay. So now you calculate, I given you number CO2, so 32,000 kilogram per kilogram or a ton of gold per kilogram, and then you say 3 gram gold you convert, it's about a ton per I think gold or something, so that's the calculated. And also one thing, staggering thing is that I have to get those numbers right, but roughly 1,000 liter of the, so we have got a 1 liter of bottled water. So in your gold ring, 1,000 bottle in your gold ring embodied water to make that gold. So, it is obviously horrendous. I mean, price of love is really not small. Obviously, that love not I am talking about, but that is what we do. Yeah, my affiliation, I started as a career in Bangladesh as a university teacher, but long time ago, I forgot even now. But that is the start. I did Khulna University, which is not far from Calcutta again, and then obviously with CSIRO, Monash, RMIT, Swinburne, I name it, a lot of universities I am associated with. So, I said my mission is use science for development. So, obviously that using LCA, using sustainability, using energy research, transmitting knowledge is that's I love to do. And I think obviously that's actually one thing I'm in the development field. I tried to understand what is happening. So, I think if you look at SDGs, right, that's sustainable development goals. I think in this field, this is I think the biggest advancement made that came through the global consensus. Now, whether we achieve it or not, that's a different story. How we achieve it, that's probably we need to think everyone. But I work and I come to work keeping these goals in mind, and if any one of you just focus on one goal, okay, so like for me 7, affordable and clean energy. So, that is because I work in the hydrogen area now, we need to give that affordable clean energy. Maybe some of these other is number 9, industry, innovation and infrastructure, particularly industry innovation because I do research, sustainable cities and communities, but that is mainly 12, responsible consumption and production, that is one of the professor talked in the morning. So, just take one goal in your heart and work for that as a student, as a person, as a academic, whatever you are, whatever you can contribute, just take one goal and then contribute for that. I think that would be good outcome for the world. Anyone has a specific thing you have learned or done with any goals? Can you give anyone example? In the back maybe? Particularly students you explore, but I believe that some of the academics you, yes please go ahead ma'am.
So I'm currently volunteering with an institute called Sherpa Institute based in the US.
Okay.
So they work with the UN to write books called as, the theme is corporate guidebooks for the sustainable development goals. So basically we kind of write guidebooks for corporates as to how they can implement the SDG goals in their respective CSR initiatives. So we had a lot of case studies and then how to establish KPIs and things like that. So and we are also looking for people to join as volunteers in writing these books. So if anyone is interested, they can get in touch with me as well.
Fantastic, that's really good work. So anybody knows what is everybody knows probably what is CSR? Anyone? Corporate social responsibility, isn't it? It's becoming common. Another, I don't know, have you heard a term called ESG? Environment, social and governance, I think. That's, do you know what's the relevance for that? Anyone contribute? What is ESG and what's the relevance here or anywhere?
Like the 3 pillars of sustainability.
Right, and how do you measure that? LCA is one of the tools obviously.
Chemicals have certain impacts created by the environmental factors on them, and LCA may be one of the tools to quantify those impacts.
And kind of environmental pillar, because environmental social, there is social LCA, we will talk about that, but governance probably not LCA, it is more representation of the females in the, you don't have the I guess child labor, things like that. So ESG, why I was telling a little bit earlier that when we used to get LCA type work, say we don't do that much external work and we don't go to the industry, they come to us, they say, oh, we want to do an LCA, I think I am talking about say 15 years ago, and how much would that cost? And we would to say $50,000, and my colleagues would tremble to do that one, or would they maybe paying it or not. Now I say no negotiation, $200,000 do you have on the table, then I will speak, and I don't know, it might go up. We are interested to do or not? They say, yeah, still interested. I said, you have to wait probably 6 months or even a year because I have got other works to do. They still say, yeah, we want to do. That's suddenly why that is come into the picture, that much control the scientists have got, and we love to have that one because we never had that voice. Even the hydrogen area, I said, do you have $2 million on the table? Then I will talk, otherwise forget about that. So this sort of things we can tell now. The reason is that ESG came into that area. So that in the stock market, the company's ESG rating depends on the environmental performance, and they need to measure precisely, and that translated with the money. So anything I think the one thing I learned that you can convert it to money and then people suddenly becomes, oh, this is a big business. And there are a lot of, if you Google LCA calculators, there are hundreds of them, and I would say probably 99% are dodgy and or not very good. So what I would like you to do, to become a proper LCA expert. That's not just claim a fake LCA expert who is putting the reputation at risk, okay? And trust you can build over time, but you can lose very easily. That's that one. All right, so what is your motivation? I believe you said some of you broaden your skills, knowledge, want deeper understanding, software. We'll cover some of those, SIMA Pro, Gavi, you name it. There are many of them. And by the way, so these slides will be given, and I believe, Shalini, they have been given, isn't it? Yeah. So if you want to take notes and everything else, you don't have to probably. To know about sustainable development and metrics, did not get chance to, this is actually came from my studies when I asked that teaching the course, why do you do that? Most of the people, and I think it will kind of resonate with your understanding too. So want to know the tools, want to see other work, and another thing that it's a very multidisciplinary work. So but best LC experts or best work I found, they came from chemical engineers. The reason is that I think we talk about the chemical engineers professor, isn't it, mass and energy balance. So we talk about the systems. So somehow because we know about the process, but it does not mean that other people cannot work in, because with engineering and science, good science, it's good to be, and then you can be good LC expert, but it's not necessarily to be. But sometimes I've seen that some other discipline people come without true understanding. You do LCA, you give some input, you generate some result and say, but what does that mean? And then the data and the quality of the data. I have been to many plants. I know exactly how much energy, how much coal they are using in the steel plant, because I think at half a dozen steel plants I've been to, and I've seen then I have the direct data, benchmarking of the operations. So that's very important also. Just be mindful of that. And obviously, yeah, so all these, so many things happening in the world, but environmental solutions you need to give, and then what are the solutions? And this is really right spot to be in. So exciting place in terms of new technology, changing, world is changing very quickly, COVID also even forced us to think differently. So now let's discuss this one. By the way, can you read from the back? It's hard probably. What is this? Tell me. Last one, probably the gentleman over there. Can you please tell me? Can you stand up, please, and read that? And what is this? If you can read. I'm sorry, your back. I'm putting pressure on, but just broadly, if you can see.
Towards clean power, India's current power generation capacity stands at 4,09,161 megawatt, with fossil fuel-based sources accounting for approximately 3/5 of the total. According to government studies, the share of non-fossil fuel-based generation capacity is likely to increase from the existing level of 42% to more than 64% by 2029-30. A snapshot of the current capacity and its resources. India's power generation capacity and sources.
Thanks. I think that's fine. That's excellent. So that many megawatt, 409,161 megawatt. We have got a lot of engineers here. Quickly give me what is gigawatt. How many gigawatt that means? How many? Gigawatt I'm saying. How many? It's in megawatt unit. 40 megawatt or gigawatt. So I'm saying, so maybe we are making some mistakes. Let me make it clear. 409,161 megawatt. So you are saying 409 gigawatt, right? Because divided by 1000, simple. 409 gigawatt. Remember, it's a big number, isn't it? In Australia, we have less than 10 times of the capacity because we have got less people, India has got large people. So 409 gigawatt power. Okay, now let's convert that one. How much, what is saying that is, let's try to make some sense out of that. If it is a total to, so I'm trying to figure out, if you say quickly, can you have a calculator, anyone? Or you can do them quick calculation that it is saying 42%. How much power is coming from solar and wind? That's I want to calculate the overall percentage share. So that's 15. So that's 61 plus 40, isn't it? 100 roughly, 26% around. So 26% is quite good number, isn't it? India is making good progress in that sense, is it? So, but does that mean anyone knows, because I don't know too much about Indian system, that this is installed capacity one thing, another thing net sent out, isn't it? That's another. So, is it instant, it is a real capacity or installed capacity, any idea? Real capacity. So, it's not sent out, right? So, say solar, tell me, say solar 100, say I have got solar power plant 100 megawatt, I said I have installed. What do you think how much I would get from that? What? How much, sorry? 60% solar. So, if I say 100 megawatt installed I have, I will get 60 megawatt electricity from solar, is it? You said. Anyone else, any other ideas? Have you heard one thing called capacity factor? I believe you know that one, right? What is capacity factor? Can anyone explain? Any engineers here? There are a lot of engineers I know. So, capacity factor, what is capacity factor? It is how
much energy we are getting and how much we are getting off, like in terms of electricity. Like in terms of turbine, how much out throughout before the shock and after the shock conversion, how much energy conversion we are getting. For solar, I think it's 0.19.
That's right, you are right. 0.19 means 19%, isn't it? So how long the plant is operating and what is called nameplate capacity, or you know that we built 100 megawatt power plant, we do not run it 100%. You cannot run 100 megawatt, you cannot get, isn't it? You generally thermal power plant we say 80% plus minus, okay. It could be depending on, because you have to have run time, maintenance time, etc., etc. So, it is about 100 megawatt power plant means 80 megawatt net sent out capacity potentially. Are you following me in the back? Following me? So, solar, the gentleman has said 19%, says 20% capacity. So, if I have 100 megawatt power plant, how much I will get? 20. So, basically one solar means 5 times more to get your demand, power demand and exact required. Do you understand that? What about wind, do you think?
The same range, 0.23.
In India, isn't it, Shalini? Am I right? In India, what is the wind capacity factor? Location?
20.5 to 29.5%.
Yes, different. In Australia, it is about 44%. We have got better wind. Wind depends on location. Solar also depends on location, but generally solar we use rule of thumb 1/5. Okay. So now, if that is the case, then you need to think about, if we say that they are saying in 2029 we are going up, isn't it? Right. So more solar, more wind, more non-renewable sources. So the amount would be very, very high, isn't it? That's one thing to note. Now, what are these? These are the sources of power, isn't it? Electricity you can make using coal, you can using lignite, gas, diesel, solar, wind, etc. Now, the job is to probably for us with LCA, what's the problem or pros and cons of each? I don't know. I mean, there are pros and cons, but I am interested with CO2 footprint of that. So, carbon footprint means kilogram and the unit is kilogram CO2 per unit of power sent out, megawatt hour say, okay, because that is the unit we talk. Now, coal is probably 1 megawatt hour, black coal if you say, we call it 1 ton, because you have to mine the coal, you have to sometimes process the coal, send to the power station, you combust the coal, you make steam, you run the turbine, you produce power, right, and then there are parasitic in the power plant, etc. You have to calculate everything. It is not just only the power plant what is happening. Same with your lignite, which is anyway, anyone knows what is the difference between lignite and coal? I don't know why they are different. Are they different? Anyone? Are they different products, coal and lignite, or different fuel? Anyone? What is lignite? Anyone in the back? No, haven't heard of lignite? That's right, carbon content, because high moisture generally, low coal, if we sell baby coal we call it kind of, because coal usually takes 300 million, 250 million years to form, because they come all from biomass anyway, because photosynthesis is the foundation of civilization, I say sometimes, but coal means biomass material transformed into black carbon, and lignite took probably little time, maybe 30 million years. In our case we call it brown coal in Australia, lignite mines, we have got many. Actually the state I live in, Melbourne or Victoria, we get electricity from brown coal. Then gas, So coal is maybe 1, I say the factor, say if you say 1 kilogram per kilowatt hour electricity, or 1 ton per megawatt hour electricity. Okay, now I say lignite, I know lignite is because lignite you have got a lot of moisture, you need to dry it, drive the moisture out, you get extra energy, and it is we had a dirtiest kind of power plant in that one, we closed it. So it is say 1.3 ton of CO2 per megawatt hour sent compared to coal. So coal is 1, okay, so lignite is 1.3, so obviously lignite is high. So in terms of percentage wise, how high is that is, can you tell me? 30% high, isn't it? 30% high. Now say gas, okay, what do you think, gas is high or low? Anyone? Low. Low. Gas is generally 30% low, so it's 0.7 we fell for factor. So if coal is 1, lignite is 1.3, gas is probably 0.7. Okay, what about diesel, do you think? Any idea? Diesel a little bit higher than coal, we have I think 0.85 or something like that, yeah. So it depends, but all have got CO2. Why? Why CO2? Anyone? Hydrocarbon, because we said the carbon content, the coal is probably carbon content is good coal is probably 80%, you know, lignite is probably 60%, gas is obviously carbohydrate, you burn it, you combust it. So if you combust it, you have to add air, right, as a sort of what they call that makeup air, or I forgot that one, air fuel mixture we burn, isn't it, and it has got oxygen in the air. So carbon and oxygen, that's your reaction, and you get the heat out, and heat you use for making kind of power. That's your energy source, and that's why you make CO2. So there is no way to make this power from these fossil sources without CO2. Clear? Now what about solar? Do you think, what do you think number would be for solar? So we are talking about 1 or 1000 kilogram per megawatt hour. So what would be, do you think, solar? Anyone has any idea? Solar would be more. Why is that so, sir? Okay, okay. Anyone has got any argument against sir? So why solar would be more? What? Batteries, okay, could be one solution, and then any other argument? Actually, it's much less. Why is that so? That's also one component, but there are more other components. So obviously, silicon smelting takes a lot of energy, but lifetime of solar energy, amount of electricity it will be producing, it will be far less. So it will be 100 below 100 kilogram. So 0.1. Okay. So 90% reduction plus even potentially, depending on, as you said, if your battery system, and that's what is called system boundary. We'll talk a lot about that. System boundary is very important for life cycle assessment. So when I say kilogram CO2, where is your system you are closing? Gate to gate, cradle to gate, or cradle to cradle, all through. So that's we'll be talking a lot. Same with, I think we will, what I want you to do, one of the exercise, you Google it, okay, tonight, that's your homework, okay. What time is it now? I think I don't know how I'm going with time. Somebody has to keep me reminding with the timing. So job is that, put another column, okay, another column and Google it. So the job, let me make the clear job, okay. So one more column, Google it and put the number, unit I want to give, kilogram CO2 per kilowatt hour electricity sent out. Kilogram CO2 equivalent per kilowatt hour electricity sent out. What is, you Google it and populate this column, and we will come, I think I'm sure some studies you will get it somewhere. I want to see everyone's number, and we want to go and evaluate and go through one after another. Is that job clear? The task is clear, right? Okay. All right. So tomorrow sometimes we'll do that one. Okay. Now, oops, sorry. I think how do I change it? Okay. So now obviously we are talking about this one. Next thing is that anyone tell me that job I usually give, but that task I'm not giving it because I will tell in the next slide. What do you think top most problematic global problem at the moment? Environmental problem I'm talking about. What is the top environmental problem at the moment the world is facing? What do you think? Sorry, climate change. What about you? Global warming. What about you, sir? Air temperature. You said. Yep. What about our participants? What do you think? Greenhouse gas emission. Sir said. What about you? Wood waste. Food waste. Food waste. Waste is maybe problem. What about do you think? GHG emission. Ma'am. Climate change. Global warming. Climate change. Ma'am. Climate change. Electronic waste. Okay. What about you? What is that? Urbanization. Electronic air quality index, that's resources, fresh water, plastics. Which one that? Global warming, sir, you? Global warming, climate change is a problem. What about ma'am? Climate change, sir. What? Clean water, e-waste, ma'am. Waste management, waste, yep, waste is a problem, yep. Climate change, Avash, what is fossil fuel extraction? What about sir? Sorry, climate change, you? Energy, air pollution, water pollution, climate change, okay, e-waste, yep. Okay, all right, and then? Greenhouse effect. Okay, so let's look at that. I don't know, I think it varies, you can Google it, but one time we found air pollution, particularly NOx, this one of them. Then climate change, not necessarily it changes sometimes order, but talk about, I don't know, I think in my notification always Prayagraj is okay maybe, but some of the say Delhi, Calcutta, always you see that one hazardous air quality, very poor, this and that, particularly this time of the year, isn't it? It's not somebody is notifying us, it's measured, isn't it? Measured quantity is just transmitted. Anyone, sorry, any comment, or is anyone making a comment or not? No. So air pollution, climate change, global warming, water pollution, waste, I think natural resource depletion, biodiversity, radiation, eutrophication, etc. Eutrophication, anyone heard of this term? Yeah, what is that? In the water body because of the fertilizer application, and that's a unit in phosphate equivalent unit in LCA. So we'll determine that exactly because of the thing we will be doing. So now you see that one, number of days above unhealthy category more than 151 in 2018. I've got that 197. So it looks like there is increasing trend or all the up and down, but say 197 days. It's or number of that many days in 2018, and that unhealthy condition means respiratory illness, other illness may trigger, and but recommendation is that you stay home, healthy resident should avoid outdoor activities. Okay, so now what do you think? This is a city somewhere, isn't it? Where do you think that city would be? Anyone? Any guess? Delhi only. Delhi. Actually, there's a Dhaka city in Bangladesh because I come from. I picked that. And Delhi is probably worse maybe, but Dhaka and particular time of the year, and Dhaka, Delhi, Kolkata. And I can tell you that if I tell we are in a gas chamber in India, is that bad to say? It is bad to say, obviously, as an Indian, and I come from Indian background, I don't like that, isn't it? Say my Western colleagues come here and say, oh, you are in, looks like you are in a gas chamber, it's very, very bad for environment. It's right what they said, right? Isn't it? I cannot shoot the messenger, it's a message someone is giving, so we cannot ignore that, right? And we have a big role because you are the cream of the society, you are the educated part of the society. Say street, whoever working in the street, say a bit of van wala or rickshaw wala or whatever, whoever, they have no idea, and you don't expect them to have any idea, isn't it? They are bread and butter, they're living, that's their prime role. We have a role to play, we have an obligation. I think it's a crime to ignore that. Actually, I was raising that one, and one of the professors said, oh, we cannot tell that one, it's not, we cannot deny the fact, right? If somebody is telling us, we need to do something about it. It's a problem, right? Now I understand that there are multiple reasons for this problem. Global, our particularly in the subcontinent, we have a very large population. We have, that agricultural products are what they call the stubbles are burnt. Yeah, various cities have various issues. So, but we need to find a solution, and I think all these NITs, IITs, the professor, the academic, the students, everyone has a role to play, particularly the science and engineering background we are coming from. We sometimes say we have a solution, but Actually I was in Delhi, Mumbai. Last 3-4 weeks I was in India, traveling a lot. Went back to Melbourne for a week, and I came back for this course. So we are discussing a lot with a lot of people, and there are political problems, this and that. But at the end of the day, there must have some solution, right? Engineering solution. And now implementation, the cost effectiveness, etc. That's a different matter. Now forget about LCA. Some people do not believe in LCA or believe in climate change. You know that one. There is a section of people, right? Even some politicians. I don't comment on that. But forget about that. The particulate matter coming from the diesel exhaust, say power plants, nobody is telling that. It is obvious. You can measure it, you can count it, you can put a sensor there and it will tell exactly, and that is what my iPhone every time is telling my watch, that it is poor healthy quality. So we cannot deny that fact, this is happening. So if we clean the environmental some sort of ways, say electrify the vehicles, that may be one solution. At least the power station will produce that emission. At least in a point source we can control. But if you have everywhere, all the car is spewing something out, it is hard to manage, and that is where hydrogen story comes in, and that is why I am passionate about green energy, green technology, and working day and night. And that is why I said 24/7 I am dreaming, sleeping, everything about hydrogen now, but I am doing other things too. So any questions or any comments about that? Did it surprise you? Did it surprise you? Anyone? Yeah, obviously global warming, and that is a bit of problem too, and this problem is so huge, so big, that is hard to manage by a single country. I was in Japan 3 months ago probably, G20 event where I represented Australia there with my chief executive Larry Marshall, actually 2 of us there, and one thing came about. One single country can solve this problem. This is such enormous. One institution can solve the problem, one person can solve, no one. It's you have to globally put. Americans have a lot of money. Their laboratories is well equipped because their one area probably have got 100 scientists working. So, but still the problem remains the same. So all the countries have to work together. So, Professor, any comment on that?
It's fine. It's really fascinating to know.
Thanks. I think we are on the same page, isn't it? We want to do something for forget about our generation. Professor's generation professor is at least older than me, I know, and I am older than you. So, but your future, your child, your children and their children, think about them, and that's all about sustainability. How we got the globe, we have to live, and that's the definition of sustainability to me. What we got, we have to live like that, and I think that's we learned from our predecessors, our forefathers, our civilizations, and particularly Indian civilization. We need to bring it back. What do you think about this? What is that? What is that? Can you tell me a little bit? I just do not. There
is an umbrella term in the sustainability.
So, but these are, what are these? Broken umbrellas, isn't it? It's nothing really fascinating. Broken umbrellas. What do you do if you break an umbrella, or say you, I don't know, I think here the weather, windy weather you get, Professor, here, windy weather sometimes. You go with the umbrella broken. What do? Put in the bin, right? Or you don't have a bin, maybe, I don't know. In Australia, in Melbourne, it's a horrendous weather. You know, we got it. Melbourne weather is sometimes, some people say, I shouldn't say that one. Like it changes 4 times a day. So some people compare with women, so or I shouldn't say that one, but that very unpredictable sometimes. It's just for fun. I'm saying, do not take that seriously. Our women colleagues, probably female colleagues. So morning, maybe you can start with very nice rainy weather. You don't feel that in the evening there will be huge rain and wind, and you always carry an umbrella or something or some jacket. Otherwise, you will be big trouble. Okay. So what we do, we take umbrella, and I see lots of bins has got this thing, broken umbrellas, because they dump it. But if you think about the life cycle assessment of an umbrella, it's really fascinating. Have you seen anyone umbrella making process? What is the biggest good brand umbrella here? Anyone know? Where the umbrella comes from, really? Okay, so you have got some engineers here. What are the, how do you make a product? You need some materials, obviously, right? Inputs. What material inputs here? Tell me. Steel, fabrics, isn't it? Plastics, yeah, you name it, isn't it? You need threads, yeah, cotton maybe. So umbrella making process, Google it. It's quite fascinating process on how umbrella was discovered. We don't have a time that much. By the way, are you finding it interesting or a bit boring? I hope you are not sleeping. That's the last thing. If you're sleeping, let me know. So that means it's time over. I need to stop. Now, Abhash, you are in the steel making business, isn't it? Have you been to a steel plant? How many of you have been to a steel plant? Can you can you put your hands up? Except Abhash, you have been to a steel plant. Can you describe what a steel plant like quickly? I mean, within one.
I have been to SAIL in Salem.
Yeah.
Where they get blocks of steel from Jamshedpur, and further it is processed into coins, which we use today. So initially smelting takes place, and then goes to sheeting process, and then further it goes to separations, and then goes to the minting plant where it is made into coins.
Right, that's you are going to a bit of downstream manufacturing process. Avash, you live near a steel plant, isn't it? Durgapur steel plant, right? You have heard of Durgapur, a place? Anyone? Everyone know that one? Durgapur in West Bengal, between Kolkata and halfway to Dhanbad, I guess, isn't it? That's the description. I get a good one. So steel plant, if you go there, I have been many of them, and obviously fascinating. And steel, in the beginning I asked you that 2 ton per of CO2 per ton. It's a specific footprint of steel is not big, but the amount of steel we generate in the world, it's horrendous. It's any idea how many tons of steel globally we produce now? Any idea? Any idea? Just give me a number, any number. I just want to toss around. Metric tons, 6 point something lakhs. I am talking about million tons. How many million tons? Globally, I am saying all the countries. Any idea? That's a small, very small number. Tell me the big one. Whatever big number you come with, and someone give me a big number. Yeah, I am talking about millions, billions. Any idea? No idea? 10 billion. Okay, that's a number. We produce 2 billion tons of steel every year. It's a staggering number, isn't it? 2,000 million tons. And next metal is probably 50-60 million tons, aluminium. So aluminium CO2 footprint is much higher, but the amount of steel we produce, it's far higher, and that's why a lot of focus. So you can see that one. So the impact of steel, you need to think about. You are throwing steel in the bin, unless you recycle. So Dr. Akshoy, how we are going with time? Okay. Okay, all right. So I give this, when I give a lecture, I give this fast slide. Today, because you don't know me, I don't know you, we did a bit of hoo-ha, but actually that's the I give and say, what do you think about that? And next time I say to them, think about the life cycle of an umbrella and before putting in the bin, because that so many steel making, there are so many varieties of steel, because I Google some of the papers, carbon footprint of steel or greenhouse gas emission of steel. I know exactly how it is happening, and quite alarming also. Yeah, you can see that umbrella making process in YouTube. You can Google it from that link I have given, and you see so many small components and so many. It's a simple umbrella. You talk about car, you talk about iPhone, you talk about aeroplanes, and you talk about so many things around us. You talk about structures, say your buildings or your bridges and anything else. I mean, we cannot live without that. So it's not sustainability is not simple. We cannot go to cave life where our forefathers used to do. On the other hand, we cannot hide and like a professor who was scolding me, oh, don't tell, nothing happening. It is probably not the case. It's happening, and we cannot hide our sort of things rather than do something. So that's in between. Maybe use the technology. We can make steel, and that's why I'm here for, I think, last 3 weeks, and not only that, another 3 weeks, another few months we'll be spending to figure out what we call green steel. So steel with low CO2 emission, and that's where we're going to work with India and Australia, a big program. Hopefully I'll be leading that one. Again, I don't see too much. I think this is probably old slide, but first paper we did quite a while ago, and that got quite a bit of CO2 footprint of mineral processing mining. Majority of my career I spent applied LCA for metal CO2 production. What is the emission of CO2 from metal production? That's why I spent a lot of time. And now obviously energy production and doing energy. I think this is now, I don't know, very old maybe, because that's now 6,000 maybe 3,000+ I would say, and this is maybe 500 citations. Now you saw this one, right? Everybody knows that one. Do you know what is this? So laws of hierarchy. So what do you need? So that those people in the street, they need that thing. We need also, everyone needs that one. Once you get a bit, you need safety, you need and then self actualization. So at some stage, so in these countries, in Australian Parliament, I think last 10 years I am looking at that, although the achievement or the progress is not, I don't know how long, how far, all about climate change. The parliamentarian, the debate about it is happening, it is not, it is now I think most of people think happening, and CSIRO is all the time, oh CSIRO scientist told that one and this and that. So but forget about that debate, it is a biggest kind of debate because that is the determining factor for politics for everywhere, climate change, okay. And it is happening, we know, because I am not a climate scientist, but my colleagues who has worked in this area, and global CSIRO model is one of the best model on that, and they say that one in this room, by the way, in this room, do you know how much concentration of CO2, carbon dioxide? 900,000, what unit? Engineers, we like units, 900,000 unit, ppm unit in this room. Okay, so what is the, you say in this room, I am not saying the total of this amount of this room, rather than I say in general, what is the concentration of CO2 in the air? Anyone else? Exactly, 413 ppm. So does that anyone feel that number? Is it big or small, or what does that mean really, that number? Anyone else? What is the biggest amount of element in the air? Anyone guess? Any chemist here? Nitrogen. What is the percentage? 78, isn't it? Something like that. What about next one? Oxygen. And what is that? 22, right? We know that one roughly. So that more or less gone. And what else there? Other gas, some inert gas, a little bit of CO2, isn't it? 0.3, we said 0.39% or something like that. 0.04%, not point, 0.04. So that's what I am saying, 0.0413. That means, so if you Google, it's called CO2 measurement, and CSIRO, you know, we are mainland Australia, and then we have got an island Tasmania. Have you heard of that? Tasmania and Australia. So northern part of Tasmania, there is a place called Cape Grim, and that is a CSIRO measurement station and Bureau of Meteorology in Australia. We measure exactly CO2, methane, and few other gases, nitrous oxide, but mainly CO2 from 1970. Okay, I am 52-year-old, so that measurement is 52-year-old. Those cores are in CSIRO in Melbourne near our office. I don't know, we have got another site, and that measurement doesn't lie. Okay, so I used to monitor a lot every year, even starting my career 20 years time. I used to see 375, 380 goes, now it is 420. Okay, so you go and Google, it is open. So CO2 is increasing, it's a not denial, and that is the cleanest air source in that part of the country. That's why we put the measurement station there. Now where that CO2 is coming from? Obviously, you know, power stations, our coal-fired power station, not only Australia, globally, metal making, it takes a lot of CO2, I mean produces, because a lot of coal is used. Anywhere coal is used, produces CO2. So now in this room, if we increase CO2, say, now actually 420 or 400, whatever number we say, 400 plus minus, plus actually, so 420. If we increase the concentration, say 500, okay, and controlled environment, temperature will go up. So that's what is called global warming, isn't it? It looks like what globe, I mean our world. So sunlight coming in and trapped, isn't it? Because that's blanket layer kind of environment, and that's why the temperature goes up, because CO2 concentration goes up. And have you heard the column called 450, target 450 or pledge 450? What does that mean? We have to reduce the CO2 concentration below 450. So now 420, it is going, I think it's dropped a bit because of COVID, it's going back again. And why is going back? We know, obviously. We are using cars, we are using electricity, everything else. It is no brainer. Now, if that goes above 450, there is a chance it will be irreversible. We cannot damage the ecosystem, what is damage happening. That's why they call pledge 450, okay? Or have you heard a term called target 1.5 degree or 2 degrees? So we don't want the global temperature to go above that. So now that's the matter of climate scientists. I'm not sure, please tell me when you need a break so we can, and then finish it off today. But anyway, by the way, I think I have got few more slides. But
if you require, already we have completed 1.5 hours past
So I think quickly I'll finish quickly a few slides, and then we will probably take a break, and tomorrow we can do. So I think the learning objectives, I think all these, it's a kind of preamble context I'm giving, and hope that is giving some motivation that why do we need to know. We have the obligation for the bigger mass of the society. You are the educated part of the society. Okay. Now introduction, obviously sustainability principle, what is LCA, I think by this time you get a flavor probably. How to do it, international standards, there are a number of standards also, we discuss about that, I will share that standard with you. By the way, you know the task today, softwares and tools, we talk about SIMA Pro, Gabi, some colleagues say that one, we will revisit that. LCA databases, all these softwares is people make software, so you need to learn how to use the software at the end of the day. It will save your time, but it is not a solution. Some people think that, but it is not. But we want to go to the software because it is more, you can you can climb a tree, or you can use a ladder kind of that, that's innovative way. Case study examples, various, I have already told, you can, I hope, I don't know, before has anyone googled my name, or because you are going to, who is going to course, put your hands up, who googled my name, at least one or two, please do a bit more, because usually I generally go, I learn about that people, that or the person, who is that, what is going to talk about, and how much credibility he has got. Please do that one, so you will get some papers I already mentioned, good to look at that, and what the result means, and how we apply that various industry sector. I always stress application. I can teach you how to play golf, unless you play it, you don't know how to play it essentially. Mining, metals, energy, environment, that's I love this space, and lot of people do not see the link. I told you iPhone to metals, and then energy to metals, energy to CO2, all these are very, very connected. So a lot of people do not appreciate that, and I will stress you on that, and not many people have got good experience in both world, and I want anyone have that one, please let me know, you have a job for you, I have a job for you. Then water footprint methods, environmental management, and etc., and where to go as a student, or if you go next, if you need more resources. So that's, I think we'll be finish it off. Expectation I told you about, and I think some of you may teach this course for others. Okay, that could be, and the teachers, perfect teachers, I can see some merits in Professor Jain, some of those, but I want you, if you are a teacher, just think about those things, what a teacher's role is, and we need many teachers like that in this world. We call it guru in Indian literature, to be guru is not easy thing. It comes with lot of accountability, lot of responsibility, and we aspire for that. And anyone in teaching profession or think about going to a teaching profession, I encourage you to look at that. Ask questions and have fun. I think that key message is I am here. Environment is everything around us. Sustainability has various meanings. Sustainable development goals can be good compass, and I told you number 7 and others. We need to think for everyone to be happy. Teaching and learning is a two-way process, and life cycle assessment is a key tool for sustainability assessment. And obviously we would like to make some fun, some jokes. If anyone tell me, I would be really get some fuel. And this is a place in Melbourne, it's called Yang Reservoir. In Melbourne we get water from natural sources, so there are many dams like that. Just this dam, you cannot fishing, that you can see that there are fenced off, you cannot swim, you cannot do anything. This water is for drinking, so it goes to under, so this is in the mountain, not big mountain, it's a kind of reservoir, so water stays there, it goes with minimal treatment and comes as we drink it. So that few reservoirs like that helping us to, we have one desalination plant though, I will talk about those stories later, and many countries have got now reverse osmosis based desalination plant. There are pros and cons, but we need to have also, water is another problematic area. So I think this homework, I don't think we should introduce today, but tomorrow maybe you have got your, these are the 2 documents we will be consulting a lot, but I think that's what to do. And with that note, I think you know the homework today, but anyway, please come prepared tomorrow. But before we finish, I think we have maybe 2-3 minutes, some key messages I want to know from you, what we learned today in this hour, or what we discussed today, and what you want, even you want to teach something, I am happy to learn also. So maybe we do that one and finish that one and tomorrow's task. So anyone, if you don't start, I will start from you, ma'am. Anything we learned today, anything you found interesting, one thing.
I learned that how little things we use, as you mentioned, choice of love, like how much of a big impact it has on our environment, and how little choices we make in our daily lives can help our environment to attain a sustainable goal.
Thank you, ma'am.
Thank you for the lecture, sir. About everything we do, every action, how will we affect our environment? And the last point about our environment is just about surrounding, how my colleague is feeling, how this class is feeling, and how my atmosphere is.
Thanks a lot. Yeah.
Environment, social governance. Environment, social governance.
That's
ESG.
right. Yeah. Thanks. Yep. Anyone else quickly? So we have to move. Just use it microphone or not.
Sir, actually today it was a very good session. It means how we are means small things matter. It really means has an impact on environment. So it should be studied.
Sure.
Thank you for the wonderful session, sir. So the various so I like that the various ton values for different resources. That was very fascinating.
Sure, ma'am. Or ma'am, you can tell, and then you can move to. Yep, ma'am.
Like how small things can affect the environment. We need to.
Thanks.
I got to know about Cape Grim. Like earlier, I know about Mauna Loa only, like observatory.
Now at least Cape Grim, another one. Thanks a lot.
Is, because of I think volcanic eruptions and all things. That is in Hawaii. Like
Sure. Okay.
Green energy is not exactly green what we think today.
Yep, that's right. That's we need to do LCA on that. Yep, right, ma'am.
You reiterated the point that we have to solve this globally and as individuals as well.
Sure,
Yeah.
thanks. We have a lot of role also in an individual. That's a good point. Yeah.
As new to the sustainability topic, got to know various the things in the form of numbers like CO2 equivalent, etc.
Yep.
For gold and other metals.
Sure, thanks. We'll do more of that metals. Yep.
Same like that green energies are not totally green, they have some impacts also.
Sure. Sir?
The session has helped us introspect into how our daily process affect in a larger scale.
Sure, that's right.
It was really fascinating to know the different facts and the figures that you told, and it's the smaller things that we neglect that affects the environment the most.
Sure, good lesson. Yeah, that and then Avash.
First of all, I want to say that the key impact of the steel and the gold, the first slide that you described about the gold carbon emissions, we been knowing to know more about that. And moreover, the green steel, concept of green steel has been something different from us.
Sure.
And moreover, the thing is that the sustainability should be drawn by individual for us to get a better sustainable life.
Yep, that's right. And not only, remember, gold is overall worldwide, gold is produced maybe 2,500 ton compared to, although gold in specific is very high. We'll discuss more. Next, ma'am.
Role of manufacturing process.
LCA. Yep, ma'am.
Actually, a very interesting topic, and I learned that knowingly or unknowingly, we are using more CO2. That ring concept, and just fascinating. That much CO2 footprint is of that simple ring. That is the one thing. We don't know the things.
And India,
to know that.
Largest gold consuming nation, India, probably that one. And we supply, we produce from Australia.
50 tons.
Probably we have to calculate. That's your homework, ma'am. That's your homework. Anyway, we'll do that one. No problem. Don't worry. Next, sir.
Sir, why sustainability is important and how LCA will be able to help to create it.
So next 4 days, you think you are motivated to learn something. Okay. Then next, please.
How the various electricity production are impacting on environmental.
Sure.
That, how much percent of CO2
Sure.
extracted.
And that's the homework today. Please do that one. Please do not forget homework. I don't like those students who doesn't do homework.
We have learnt about some facts about towards the clean power and some top environmental problems, and a small example of life cycle like of umbrella.
Thanks, Shalini. On the back, probably, ma'am, or maybe sir. Yep, you sir.
So take any one goal of the SDG and work on it.
Yep.
And the other one is to look take any simple product and examine it in components at a very minute level.
Sure. Thanks, ma'am. Well, thanks, sir.
Sir, how the manufacturing of this small pen affect the environment? That's a major issue for us.
Sure. Next.
Sir, how would LCA help in decreasing the environmental effects?
Right, ma'am.
Sir, how would the different materials, small or large, will cause or produce how much amount of carbon dioxide in our environment?
Sure, that will be going to look at bit more detail. Yep.
Sir, about environmental problems.
That's right. You know at least now it is the top one. Yep.
Sir, I would like to say that that was very fascinating, the various carbon emission produced by the various power sources. And I also want to focus on that you have talked about the gold. In solar photovoltaics also we use very little
Amount of gold. Not only that, only electronic goods, circuits. Yep, that's the biggest. After jewelry, that's the biggest use of gold.
Yes, and it is a major issue
yeah,
for
it is
PV
going.
technologies.
We'll talk a bit more about that.
Yes.
It's a big problem.
Thank you.
Next, sir.
Thank you, sir. It was very informative sessions, and we have learned most about how the major concerns related to the environment.
Sure. Yep.
So
You.
thank you for the lecture. I have learned interesting facts about the India's power generation.
Sure.
Thank you, sir, for such an energetic session. And sir, as you are discussed more about the metal, but I'm expecting you some polymeric material.
Sure, I'll cover that also. I'm not only metal expert. I've got some other things to share. Definitely. Why not? And ask if I don't cover. Please remind me. Okay. You. Yes. Thanks. Sure, we look at that. I'll share the standard. Yes, you sir.
So it was a nice introduction about sustainability, and correlating it with umbrella example, taking all the components into account. How can we start with small components and finally communicate to larger one that we learned today?
And you.
So how small behavioral changes even with current technology can go a long way,
Right.
and not to believe on numbers.
Sure, exactly. It has to be numbers because you say it's a good technology. Where is the proof? Anyone else has left out or have not commented? Okay. So, sir, you want to comment what we have got so far, or it's just general comment? I'm not saying what you learned because you are an academic.
How these different manufacturing processes will help on that LC. I am very new on that field.
Sure.
So I am trying to understand how there are different manufacturing processes are there
Yeah.
which can help to on this LC.
Thanks. And you? Okay, no comments. Professor Jain, you come in front and tell something about us, what we should go about and finish the day today.
Actually, I was looking forward to be the student in this class, but I never knew that I will be examined off and on like this. I am actually not prepared for it. But anyways, it's good to be here. I visualize this whole thing in a slightly different perspective, which I've never thought of earlier. That we as a human being living in the atmosphere, and we can live without water for a few days and without food for a week or so, but we can't live without breath even for a few moments. Okay? So the air around us or atmosphere is the most important for human being. Okay? So we know that there is oxygen, nitrogen, but very small percentage of carbon dioxide can influence so much. That is really fascinating for me today. Okay? Just changing from 0.04 to 0.045 percentage can make a huge difference. Because in mind and perception, we have a feeling that maybe how much it can influence. Okay? But as I understood today, I do not know whether I understood correctly or not, it can make a few degree changes in environment. And that degree can influence your seasons, your global warming, and many other effects. Okay, so we have to be very cautious about this kind of a thing.
And then the next question which comes to my mind is that out of all the sources which are generating CO2, which are the top culprits? Okay, so that I can focus on one by one and can perhaps find solution for it. So that would be my next question to you, that I would like to look forward to knowing what are the culprits which are making it from 0.4 to 0.45, and if I can really stop it, doing it. Thank you.
Thanks a lot, Professor Jain, and we'll be moving that more in that direction anyway, and that will be next homework, one column after another column. So at least give some idea what homework I have to give. Anyway, so Dr. Akshoy, finally finish it off today. What's the instruction, what they do, or what is the expectation tomorrow and where? By the way, are we interacting with our online participants? Are they on board? Do they know? Okay. Oh, join, I see, okay, all right, okay, otherwise recorded, session is recorded, right?
Yes.
Okay,
so
all right.
Stop.
Oh, sorry. This one? Second one, this one? Okay. So you have got these slides or not?
Another lecture.
Okay. Okay, all right. I think we should start. Let Sada join when they come. It's already 5:09. So everybody had a bit of refreshment, right? All good? Okay. So now, last time we didn't talk about questions. So anyone have subject specific question? I want to, before I start, I want to go that to now. Anyone has got any question? No questions so far. So, but anything you can talk about, anything you can discuss and ask question, or comment or suggestion. How I'm going? Yes, you want to say? Yes, go on.
Sir, those softwares are we going to practice something, or we are going to analyze LCA about something?
We will do a tutorial using that software. Okay, that's you will have to do that. That's I'm going to instruct now. Okay. Anything else? EV vehicles, specifically EV vehicles, I will not specifically be able to talk, but let us discuss, and if you are really interested, anyone interested on a specific topic for you, you have to develop your concept understanding based on the decision, based on the foundation or knowledge I give, okay, or the experience. But there is a way of doing it. You work with me and also talk with Dr. Akshoy, will help you to develop your LCA. 5 days you cannot complete LCA, obviously, isn't it? 5 days is just to get the understanding flavor, hands on software, do a bit of tutorial, and we will implement that for your project. Make sense? Clear? Anyone else? Any other? Yes, ma'am. That's right. Yep, there is a protocol. We will discuss about the LCA standard. Okay, so that's, sorry, is that everyone? Anyone speaking or anything? It's okay. All right. Now, before we start, few things I want to show you. The next session, not many slides, only few slides, but we can discuss, and it's, I want to question and discussion kind of activity. This is the brochure CSIRO, Australian National Science Agency. I discussed about that. These materials not for your taking. You have a look whenever you have got time. You during tea break, it will be staying here for 5 days. Okay, so you take, and finally probably I'll leave it. That's whoever take it. That's, or maybe I'll leave for the department so that they can utilize for future students and others. So, but you, this is for your reading and have a look while you are here. Okay, just a hard copy. These are all information on the internet. Also, you can explore that one. So, this is about CSIRO, various research activities, what we do, etc. Just one brochure. This one we have got few brochure probably, so you can probably have a look, resourcing the future, and that's what aspect of mineral research we do. Okay, so this is quite good information there. I think I'm just having a look. That's our Center for Hybrid Energy System, hydrogen demonstration plant. So, few information you can bits and pieces you can see that one, and I think that's it. The other one, Australian innovation for a global industry. So, now the lot of technologies we developed for gold, mining, etc. If you are mechanical engineers and any engineers, because mining industry is big, they employ all sorts of engineers, all sorts of professionals. So, if you have interest to go to Australia, I would recommend to have a look, and there are a lot of jobs, to be honest, available, and I don't think we are taking enough, particularly from Indian background. Lot of roles are filled out by South African engineers, and because they know and they have similarity. India has got big, and it's not necessarily you need to have to be mining engineer, any engineering background you have got role. The other one is the obviously I brochure life cycle assessment, hydrogen energy system, techno-economic evaluation, and I think couple of papers, and one of the I see that one, that's all right. So, that's anyway, this you can have a look of that. One of the, I think these are the papers we have already given with your course note. Or that if not, Shalini has not given you, Shalini make sure that you have given. One is the application of LCA assessment for assessing environmental impacts of mining, mineral processing and metal production, and that's we produced last workshop we did in India 2014, and it has got list of all papers, and I know Shalini has been downloaded a folder of our papers. Since then, that was 2014, I think last 6 years we have produced a lot more papers. So, that's as much as you can your bedtime reading. Life cycle assessment of drying system, that's a book chapter I published 2015 with Professor Arun Mozumdar and others. So, that's a very good intro, early level of LCA, intro to LCA kind of thing. I recommend that one, and some other materials in LCA, hydrogen refueling station, some of the rooftop solar news, I can keep that. The other one I want to mention, this is the all energy event and waste in recently in Australia happened. You just look at the topics and areas, then you can feel for, and companies basically all about in Australian energy systems and waste system, okay, those who have got interest in. And these are lots of magazines, it's called Resourceful, that's Australia, that's our CSIRO, critical minerals for example. There are lots of other topics, and I have brought for, I think there is monthly, this is probably last 3-4 years we have produced. These are all on the online, by the way. If anyone is interested to have a look, you can look at what do we mean by critical minerals, what do we mean by green steel, mainly mining industry specific, but some social, as I said, mining industry is, we say mining industry, but it's all around various industry sectors. Have a look. These two is my own copy, but you can have a look. Sustainable mining initiative in India, which companies are involved, what they are doing, and skill council for mining sector, and that's again for your having a look. Various companies like Nalco, Rio Tinto India, Tata Steel, Vedanta, Rangta Mine, then Geological Survey of India, Hindustan Zinc Limited. Some of the companies I have relationship and worked with, both in the government sector and private sector in India. So, you can have a look who are the players here. So, that's for your use. So, I think just for reading and exploring, and whenever you have got off time or break time you want to do that, most for your use. Any question in relation to that? And majority of the thing you can get online. Yes, ma'am. Okay. Yep. Yeah. Anyone. Yeah. Anyone can have a look at that. All right. So now, I think we have talked a lot about LCA in the first hour and etc. Lots of different topics. Now I'm slowly I'll move into specifically to LCA. Okay, and will be deep kind of LCA end, because that's your objective. We can talk a lot of other things, but at the end of the day you need to know LCA. That's what it is. Sustainability, some of the definitions, and what next homework, I don't want to go there now, but I'll discuss a little bit of that. But again, the definition of sustainability, not necessarily LCA, and there are few aspects of that I want to cover still. I think that's good to have that knowledge, because people have different aspects of that. So, I think this is the stock market. They say that what is the most effective way to lower your carbon footprint. There are many ways, and I think professor was asking what are the solutions. We talked about problems. It's very easy to talk about lots of problems, but where are the solutions, and that's the ingenuity of human, and I think we need to provide solution. Engineers, scientists, we are academics. so some people say, oh, shorten your shower by just 2 minutes. I mean, it's in most in the Western countries because we use lot of water in various ways. I mean, even flushing, we use lot of water. So, but how to make that water back used? In Melbourne city, we call it 450 gigaliter of water used every year. It's a huge amount. One desalination plant, it's largest, one of the largest in the world, it produces 150 gigaliter. So, that is 1/3 of Melbourne supply can come from desalination plant. So, now we are desalining, we are using it, we are discharging in the sea again, back in the river or sea. This is a huge amount of resources. Even that say 150 liter, 50 gigaliter water, if we can convert to hydrogen or something, that can change the landscape. And reusing, some of the countries I know recycling water a lot, like Singapore, some of the European countries, particularly Singapore, they use, I know at least 10 times plus apparently they use recycling water going back and forth and then cycling. In Australia generally I do not have people due to, because we have got a lot of water, they do not want recycling, but I have got 2 taps in my home, one is for recycling, one is recycled water, one is normal water. Recycled water we use for car washing, for gardening, things like that. And you remember in the world, do you by any way understanding how much fresh water in the world, do you know how many percentage? Very small percentage, 90% is saline water, and within that 3% drinkable fresh water component is very small. So, some of the academics who are expert in water, I am not, they put lots of bottles and take one after bottle another, and I said what is happening, and then finally a very small bottle, probably even not a full bottle left, okay, because that means the fresh water component in the world is very small. Then take one or less international flight per year, it is hard for me because I travel a lot, but again people are thinking about running flights on hydrogen or biofuel you talk about. So, lowering the footprint, and there are many ways, you know, in the flight they recycle the now everything basically. So, that previously those things were not very easy to do. Before going to LCA, let me speak about what we say scope 1, scope 2 and scope 3 emission. Have you heard of that, these terms, anyone? Scope 1 emission, scope 2 emission and scope 3 emission. Remember these terms, or just now I am saying, I will come back to this because that will be part of the whole discussion. Scope 3 discussion is scope 3 emission. For example, I take a flight, this is a scope 3 emission for CSIRO. If you are taking a flight on behalf of your company, that's called a scope 3 emission. So, why is that? What's the relevance of that? How we reduce that? That's a different story, and we'll talk more. Take the train instead of the car, obviously public transport promoting, that helps. Eat a maximum 1 piece of meat each week. I don't know, there are pros and cons each of these solutions, because meat apparently produce, particularly cows and cattle meat produce a lot of CO2. And obviously countries like India, whereas veg population, I mean vegetable eating population is high, although I am not, I am eat also non-veg too, but at the end of the day that has got some implication obviously. Switch your investment portfolio to sustainable funds. Actually that's because I told you ESG, anything you relate with money, people will suddenly, that's your purse or wallet, once that hits you get up and down and jump, you do something, oh, I want to save this money. So, that is a switch investment portfolio, and that is a share market related, that companies are very important, particularly private institution, they are very scared about their share price fall down suddenly because of ESG score. And all these have an impact on CO2 emission, but surprise research suggests that number 5 generates 27 times greater improvement in a personal carbon footprint than other options put together. That is more sort of private business point of view, okay. And then we will talk about public, private. In LCA there is a term called weighting, okay. Remind again, these are the things we will be going back and forth again and again. So, more LCA. Now, sustainability, I do not think we want to go detail, I mean this is a kind of one of my sustainability, actually I brought in this area, one of my mentor like Professor Jain here, Dr. John Rankin, he was the chief scientist of CSIRO, he is still an honorary fellow, he kind of recruited me. He was one of the best metallurgists I know around and good chemical engineer also. He led various things in CSIRO. Google him, I think I'll use his reference also, I'll give it. It's called Metals Minerals Sustainability. It's a kind of Bible. It was published in 2011 by CSIRO publishing. So, I recommend that also. I am hoping that somewhere I have put that references, use that one. So he uses this kind of definition. So, what is it we are going to keep going continuously, and how should we go about it. So, that is, so when you talk about sustainability, there are many definitions. These are quite common, is not it? You have seen these slides before. Social, environmental, economic, and sustainable is that which encompasses all of them: bearable, equitable, viable. And obviously sometimes we say economy, I mean we have already defined. I mean, you told that lady doing MSc in environmental engineering at the University of Allahabad that environment is all around us, isn't it? If there is no environment, we do not have an economy, we do not have any society. A lot of people do not appreciate that, particularly we think, oh, economic development. What is at the cost of society, at the cost of environment? I would not buy that. I do not want that development which is damaging something. I mean, this is I do not know, I think this we should not backtrack those discussions, that you know, there are a lot of documentaries about Ganga river, right, isn't it? Have you seen any BBC documentary on Ganga river, particularly the water quality of Ganges river? In Allahabad there is a Sangam, isn't it, Professor? And we say we take a dip and we get sin free. Obviously that is a faith and belief, but what about the quality of water in the subcontinent particularly? I am really I can say that one, we worship rivers, this river, and it is, we should worship river. River is the key thing civilization grow, or key sort of area. What is the quality of water? Why cannot we maintain that, and what is the reason for that? There are lots of you know, it is a complex problem. Actually, Professor Dr. Akshoy, your teacher, gave me a book on Ganga. There is a mission, isn't it, Professor Jain? What is that Clean Ganga mission? Hope that helped to achieve some of the solution, but we have a lot to do. We can go in the, I wanted to get a deep in Triveni river. One of the colleague in plane, I think, said don't do that, that's very, or you can do that if there is a lot of flow of water, or you need to make sure that the water is good quality. I mean, our generation used to take you know, Ganga river is a purity, and a lot of application we had. But if you can, and I know that some of the academics in that documentary, I saw that he revere that water, he is deeply religious, but he do sort of objectively what are the indicators and do they qualify for that, and that is, we are making this problem, isn't it? It is not someone else that coming to that, polluting that river. So, we need to make sure that water system, and that is why environment, water, waste, these are the key issues. We have passed iron age on all sorts of ways, now it's waste is a big concern. So, now like, so as I said, I will go into deep into LCA and sustainability area. So, selection of sustainability indicators, specific technologies, scenarios, then environmental assessment, economic assessment, social assessment, and that is how we make decisions. So, now do you have any student from economics here, background, or have you studied economics in the any way? What does that mean? What the economics I mean they want us to do? I mean, what economics look for? Money at the end of the day, profit, isn't it? Yeah. So, that is the bottom line. But and then that is means, say if we want to have a large hydrogen plant, or I want to say in Allahabad city, or in the whole India, I want to modify all the petrol vehicles into electric vehicles. Okay, there are benefits, or hydrogen vehicles. Okay, there are benefits. What is the problem with that? What do you think? Why not people are doing it? Cost, that capital cost. A hydrogen car is at least, I don't know, 30,000, 40,000 more. Even electric car is expensive here, is it? Or how much expensive? What is it? Say I want to buy a typical most popular petrol car. How much is that cost here? 6-7 lakhs. And what's that brand? Maruti Suzuki. That's a typical brand. What about similar electric vehicle I want to buy? And is there any electric vehicle? How much is that? 12 lakhs. So, it is double almost, isn't it? New vehicles. So, that means that capital cost is the one of the problem, isn't it? That the car cost. I know the running cost is very low, isn't it? Compared to petrol, I believe, isn't it? So, but people want a capital cost. So, you need to assess a piece of technology, and Professor, you said what is the solution? We need to do this kind of assessment, obviously. Then what we call levelized cost. Anyone have back in the, I think it is after we are getting a bit longer time and a bit tiring, and you might be feeling sleepy, but give me some help me. Anyone understand what is levelized cost? Have you heard this term, levelized cost of electricity, LCOE, levelized cost of electricity, levelized cost of storage, levelized cost of hydrogen? Do you have any understanding of that? That's exactly right, capital cost. For example, I can give you say nuclear power plant, okay, nuclear power plant to build or make and run or commission a nuclear power plant, it is at least say nowadays more, maybe I can give a number 10, at least 6-7 times more expensive than a coal fired power plant, okay. So, coal fired power plant say I do not know $2 billion a gigawatt, I say the nuclear power plant will be $10+ billion, okay. Now, the running cost is much lower in nuclear power plant because you use very small amount of uranium. If it is a coal fired power plant, you need a 3 million ton of coal stockpile, at least say black coal, depending on brown coal it might be even higher. And so the now you get the net electricity, and a coal fired power plant may be 40 years lifetime, a nuclear power plant may be 60 years lifetime. So, you need to look at over that time period how much electricity is produced, okay. And so, you need to consider the capital component of that cost, what that lady said, and then calculate what is the rupee per kilowatt or megawatt hour electricity sent out. That is what is called levelized. So, whenever people say, oh, it is cheaper, it is expensive, do not buy that one, because you need to do that overall, it is called life cycle costing. Do you understand that? Have I made it clear, everyone? If someone asks you what is levelized cost of electricity, can you tell now? Okay, so that is very important. So, levelized cost or annualized cost, gross domestic, these are the sort of economic assessment. Now, social assessment, I am not a social scientist, I do not know, I think somebody here talked about social area, is it social impact or something. So, then human health, safety, security, intergenerational issues, public accident, etc. But my expertise in the environmental LCA, I call it ELCA, okay, ELCA, and that we will be talking mostly. I am not going other areas because I do not know much really. So, global warming potential, what is that thing? Anyone have any idea what is GWP? Yeah. More than, why it is that? Why is it is 25? That is right. So, that radiative, that absorption, but it is essentially carbon dioxide is a reference point. Carbon dioxide 1, so global warming potential is for carbon dioxide is 1, okay. So, anything other gases CH4, you said methane 25 times, because its respect to carbon dioxide is 25% more potent in terms of warming the globe. So, but overall methane emission is not much in the world, it is more CO2 emission, that is why we are concerned with. Nitrous oxide, it is 300 times nearly, 256 times now, revised a little bit, more potent than CO2. So, CO2 is sulfur dioxide, for example, not sulfur hexafluoride, it is a very bad SF6, isn't it? So, that is refrigerant gas, it is a 29,000, 26,000 or something like that, isn't it? So, quite large. So, that is called global warming potential. So, if you produce 1 kilogram of CO2, you produce 1 global warming potential. Does that make sense? Anyone in the behind any confusion? We will discuss more about that anyway. And then resource depletion, smog effect, energy consumption, greenhouse gas emission, these are all not only that one, we will talk about that, and then you put in a decision framework. We are not going to do that, we just, because you need to generate this number and it is quite complex enough, and then you do economics, standard people can do that, economist, and then social, you put them together. So, that but all about, we call it LCSA, remember life cycle, LCA life cycle assessment, LCSA, what do you think it would be? Life cycle sustainability assessment, must be somewhere here anyway. So, environmental data, inventory data acquisition, at the end of the day data, you need data, okay, input data, how much material going in, how much energy going in, what type of energy, is it electrical, is it thermal, etc. So, then LCA environmental dimensions, LCC economic dimension, I said ELCA, that is ELCA, that is SLCA, sometimes people call OLCA, SLCA for social LCA, OLCA is for organizational LCA. So, mainly these three terms you will be listening to, ELCA, SLCA, OLCA, and then finally obviously that OLCA is a kind of context. If you apply all these in an organization concept, for example MNNIT, Motilal Nehru sort of Institute of Technology, National Institute of Technology, what is the carbon footprint of that? I want to do LCA on MNNIT, then probably that's called the OLCA. So, then sustainable development, we say Bartland report, that is our common future, that we defined that one, the meets of the current generation and also keep for future generation. So, I think the sustainable development. I think that's probably more. At the end of the day, it's a kind of, I would say, balanced economic, environmental, social development. That's what is sustainable development. And for example, a city, okay, we call it a spider diagram, isn't it? That's also you will see a lot in LCA, because we develop number of indicators, or we determine number of indicators, not a single indicator. Not only CO2 emission, what about eutrophication, what about toxicity, what about ozone depletion, and so many other impacts. So that's why, and similarly, so environment ecology, you say materials and energy, water and waste, or water and air, flora, fauna, everything basically ecology related, culture related, and that's how the circles of sustainability, that is one of the example template for example Sao Paulo city. So UNEP, United Nations Development Program, they have developed a lot of programs like that, and I recommend you, it's not only when you talk about you finish a degree, your jobs, where is your jobs? You go for government, you go for private, you go to national jobs. There are a lot of international jobs, UNEP, United Nations organizations, they look for this sort of expertise, and not many, really big shortages of this kind of people. So if you develop something within yourself, and you don't go to the classes or lectures or courses like this, maybe you do, actually the courses like this you can Google it, LCA, standard LCA course, at least few $1,000 everywhere, and a lot of people, not a lot of people I know, but few good quality courses. I think even the MIT has introduced, probably Harvard has introduced this course, and I know one of the gentlemen, he charges in Australia at least couple of $1,000 plus. So below, I think MIT, Harvard, they in the $3,000 mark plus at least. So this sort of courses you are doing, I can tell you it's no worse than those, even maybe better, because I know those people. But yeah, obviously it's a good source, and nowadays information is everywhere. I mean, we are discussing with Professor Jain, when we did PhDs, we had to go to the library with index, and whole day maybe I can get 3-4 papers and photocopy it. Then database came, and now information is everywhere. So obviously life cycle, when we say resource, that's where mine is, you extract, conventional mining, processing and manufacturing. I spent a lot of my career time around this area, and then obviously transport it, use it, and once use phase goes, either you send to landfill, this is the current system. We want to close it, what is called circular economy, you know that one, just you close everything, and so that nothing goes out. A little bit will still probably might go out, you need to manage it, but as much as cycle you through, and that will probably solve some problems, at least 80% of the problems. If you 100% have circular economy, I would say 80% problem gone, and that's the hydrogen energy concept, solar and wind, convert to hydrogen, convert to ammonia, convert to urea, because from air, nitrogen, lots of nitrogen, if you have a lot of green hydrogen, you mix them together, it becomes NH3, NH3 plus CO2, it becomes urea. And worldwide, fertilizer use, particularly countries like India, subcontinent, we use on rice, and rice takes a lot of urea, and our body is essentially urea, 90% probably, because we eat rice, and so it's a cycle. And if you have everything from the air, you cycle it, still it is costly, but you can do it. Technological solutions are there, and that's what we are working, making it mainstream. So if you say strict definition, if you look at the standard, LC standards, we are talking about now, anything you do as an engineer, ask, is there any standard? Is it national standard, local standard, or international standard? Particularly, where is the international standard? Because you need to follow the protocols, and everyone follow and have the same result. If you don't have the standard, then that's a bit of trouble. I ask those, there will be a lot of variation in answer. It's hard to rely on, so you need a standard. So ISO 14040 series, we call it, ISO 14040, 42, 44, ISO 14044, that's the latest one, I would say. 2006 international standard, ISO, you know that one, right? International Standard Organization. That's the standard we need to go through, we need to look for, okay? So that's ISO standard. There is a ISO 14046, that's a water footprint standard, specifically LCA for water. So consecutive and interlinked stages of a product system, from raw material acquisition or generation of natural resources to final disposal. That's the life cycle. What is a life cycle, and what is life cycle assessment? Assessment means compilation and evaluation of the inputs and outputs and the potential environmental impact of a product through its life cycle. So just look at that. I think that might be, I would be asking in the question, exam maybe, I don't know. Sorry, any? Oh no, so I think they are talking. So, science is a systematic method of knowledge organization which should be repeatable. At the end of the day, you do LCA, I do LCA, someone else do LCA on certain things. It has to be repeatable. It's not you say something 100, I say 10, must be there is some problem, because engineering does not work like that. And obviously engineering is the solution applying scientific principles, and we all know environmental science is understanding of principles and theory. We are talking about part of environmental engineering here. Environmental science particularly, LCA has generated a lot of environmental science thinking. Environmental engineering is about solutions and design, and sustainability is making sure the need of future generation is maintained. That is kind of boils into that statement. And life cycle assessment is a key tool for sustainability assessment. So, you need to have some metrics. I think particularly engineers, we love numbers. It is a not subjective thing, it is objective. How much exactly carbon has been used to make steel, we know that one, and we can calculate that, we can quantify how much CO2 is generated. So, I think homework 3, life cycle assessment of wooden shed, that we will be doing, okay. And for that one, not 3, I think I am sort of forget about that. Your homework is tomorrow, you know that one, but this will be one of the homework. Towards the end, we will generate what is the LCA of this. This is the first exercise. If you can do it, you can claim some competency as a beginner of LCA, and we will do that using software CIMAPRO. CIMAPRO will be using. By the way, now the question is that you have got demonstration version of CIMAPRO. Have you got that executable file version in your material? Shalini, can you help me out? Have you given them the CIMAPRO exe file? Not yet. So, tomorrow, sorry? Yep. So, tomorrow, maybe tomorrow, make sure they get CIMAPRO exe file. Okay. Do not do anything with that. Okay. First, just hold on to that. Okay. That exe, that's a, because that's a demo version. You don't have a proper version. Proper version cost money. So, what I want to do, you want to install, maybe you can try installing it. It is a simple installation process in a sort of Windows environment or something. I think Windows, you need a Windows software, I think. Before then, those, I think that lady told me that a slide, you remember that you took that last slide, CIMAPRO PDF, 2 PDF documents. Oops, sorry. So you are okay? Okay, all right. So those 2 documents, PDF documents, download that. But or do you have you given them that PDF documents to introduction to LCA with CIMAPRO, another CIMAPRO tutorial? None of them you have given. Okay. So send those 2 documents. Okay. I would like you, not today, because today you have got other task for homework. You have to go through particularly introduction to LCA with CIMAPRO, that document, and tutorial, CIMAPRO tutorial, that document later, because that have got instruction how to install the software. It is not a big deal actually, you follow the prompt, any software installation you should be able to do that one. So, but do not start the software, because we will discuss what to do, etc. Just get the software, maybe install, or at least have a look at those documents, so instruction for installation, etc. That is what we need. Okay. By tomorrow, by this afternoon, if I say that, have you installed software, CIMAPRO software, you all have to say yes. I want everyone hand yes. Okay. If any issues, then we will help out, and Shalini can help out, and also we will be there for you. But it should not be big issue, it should be straightforward system. Now, once we do that one, following day, not tomorrow, we will start the tutorial, actual tutorial itself, step by step we will do that one. So, until that, so first task obviously your that listing of CO2 footprint. Second task, by the way, that one I got, I think I came in Delhi, I was looking at Times of India, maybe I just picked from there, because I do not have Indian energy, what is that, although I have a bit of idea, but that was exactly just few days ago. So, it is a good source of, they got it from Lok Sabha material or something, so maybe parliamentary proceedings or something. So, I assume that correct probably in until 2021. Anyone has got a better number, what is the current energy generation mix, let us know also, please bring that number, but I would like you to recommend copy those number in an Excel table and put, so one column is that energy source, second column is that you know that they are saying number of megawatt, third column is the percentage, and fourth column you put your kilogram CO2 footprint, okay, and then we will go to the total and we will see Professor Jain's question we want to answer, where is the who is the culprit, where should we target, so probably hopefully we will get that some indication on that. So far do you have any question what I discussed? Is the homework task clear? Who has not, who needs a clarification in terms of homework task, please raise hands now. Otherwise tomorrow I will go one by one and I will tell that you have not raised any question. Tomorrow do not come back and tell me sir or mister I did not understand that. So this is the time now to discuss, okay. So first was that task and second one will be given the material, but that is tomorrow we will discuss. You do not have to do anything tomorrow. So maybe day after tomorrow we will start the tutorial. Is it clear? I do not know how we are going with time and what is the instruction like, but I think today this is I wanted to cover. So just let us wrap up, okay. So what we learned today, again we sort of got the context, okay, why do we need to do LCA. Energy system is a big part of that, and that is why I gave that slide. I was looking for some information, I got it fortunately quickly, I just took that snapshot and put it for you, where the energy coming from, what is the mixture, and it does not have to be, you do not have to be rocket scientist or anything, it is anyone, it is a simple common sense where the energy coming from and how much is that, it is probably good knowledge for us, but we want to fill out that column as I said. And then third thing we covered is that overall sustainability, LCA, social LCA, OLCA a little bit, I am not going there, social LCA, OLCA, I am mainly focusing on environmental LCA, global warming potential, carbon footprint. The reason is that majority of the people are concerned about that, and we know global warming, climate change is a big problem, and that's the reducing that is the biggest challenge. And I would be really happy, or not only happy, I will appreciate if anyone has got good ideas how we reduce CO2 and decarbonize the economy in a personal level, national level, whatever way you talk about, and anyone you see tomorrow you ask what is your carbon footprint, and you assess yourself also what is your carbon footprint and how we can determine those numbers. I hope you have got some flavor out of that, okay. Alright, so Shalini or Dr. Akshoy, I do not know where he is there an instruction, Professor Jain, we have got hopefully got some.
I think it is the nice day, it is the first day, we should not have too much bombardment on you, so you will feel burdened there, okay, so it is nice. Before we disperse, if you have any questions, query, any clarification regarding arrangements, program, course, any issues.
Any feedback about how I am going, is it too fast, too slow, or right, or it good for clarity, was it okay?
So you can prompt, feel free. Okay.
And we are peers, I mean so it's not.
We are here for your benefit, so whatever way suits you, please let us know so that we can modify and improve ourselves to your requirement. Okay. So tomorrow we will have a specific problem solution, so then you will be in a better way to appreciate. Okay, so be ready with this software.
And I will be another 15 minutes here, maybe I will be sort of until 6 o'clock. If anyone to just have it speak with me, that's most welcome. Otherwise, have a very good night. And just today you arrived, you had a lot of travel, I had wherever you come from, just have rest also, have a good sleep. So tomorrow you will be prepared with me. Also, I need also good sleep, although I can cope with Australian time. Sometimes I get up 3 o'clock, 4 o'clock in the morning, but I try to sleep as much as I can.
So tomorrow the session will start early in the morning. So
what time tomorrow is starting, Salini? 9 o'clock, okay. So Dr. Akshoy, we have finished the today more or less what we wanted to cover. Now up to you, and I will be here another 15 minutes until 6 o'clock. Just anyone wants to talk to us.